Hello guys, welcome back to my channel based on African motives. Still working on O-level mathematics. In this platform, we are going to focus on the question paper which was written in June 2014. That is paper 2. So this is a full paper that we are going to focus on. So I think yeah, everything is clear. The additional material, make sure you've got these things. And also make sure that you read the instructions and so forth. So these question papers, actually we're answering 3 questions in section B, but now remember that you are now answering 4 questions in section B. So in this case, we're just going to revise everything as usual so that you'll be able to understand each and every concept that you're given in this platform. All right, so without wasting much of our time, let us quickly rush through the questions that we are given. So we are given the first part of section A, that is answer all the questions in this section. So in section A, you are supposed to answer all the questions, even on the current question paper that you are having. You're going to answer all the questions that you'll be given. All right, so without wasting much time, let us quickly run through these and see what we are supposed to do in this case. So the first question is to simplify 0.85, that is on item 1, 0.85 minus 0.6. Give your answer as a common fraction in its lowest term. So this is paper 2, guys, nothing to worry much. You just have to simplify here 0.85 minus 0.6. Make sure that the commas are in line, and here on 6 we have to just put a placeholder since we need to make sure that these numbers are in line. So it's 5 minus 0 here, which is 5, 8 minus 6, which is 2, comma here 0 minus 0, which is 0. Okay, so this is our answer, but take note the answer is needed as a common fraction, so which means I have to convert this 0.25 to a common fraction. How many decimal places do I have? I've got 2 decimal places, so that means this is going to be 25 over 100, which I reduce. This part is going to give us 1 over 4. If we reduce by 25, 25 and 25 is 1 into 100 is 4. So that is what you're going to obtain in this case. So take note, guys, about the instructions that you'll be given. So this is 1 over 4 as a common fraction. Okay, so I hope it's clear there. Then item 2 is a fraction. Those are fractions that you're given. So the first thing is to make sure that you write this as improper fractions. So I'm just going to do the calculation on this part here. I'm just going to push here. Let me just indicate the part that I want. All right. I actually need this page to come back to its position. All right, so something like this, I'm just going to shift just maybe here. All right, so this is our item 2 where we've got 1 3/4. So what I'm going to do on this part, make sure that you just rearrange. So this is item 2, guys. I'm just pushing here so that I can just be able to write properly. Make sure that you convert these to improper fractions. Remember, you multiply, then here you add. So it's 4 times 1, which is 4 plus 3. That's 7 over 4. Divide by, okay, we move on here, we multiply, then we add. So it's 5 plus 2, which is 7 over 5. Then plus here we multiply again, we add. So it's 8 plus 5, which is 18. So this is going to give us 13 over 8. Okay, so we are done on this part. We have to simplify, guys. This is the fraction. These are the fractions that we are given now. Forget about that part that we had. Now there's a new question. So remember your board mass. What are you supposed to have in this case from our board mass? That means we have to have division. Since we do not have brackets, we have to move on to division. These 2 here are dividing. So remember you have to introduce multiplication. So that's 7 over 4 multiplied by 5 over 7. The moment you introduce multiplication, remember what is happening, you invert the second fraction. So it will be 5 over 7. And here we've got a 13 over 8, which is adding. So here we just have to add plus 13 over 8. So whatever that we are going to get after multiplying these 2, then we have to add to 13 over 8. So here we can cancel the numerator and the denominator. They can cancel that 1 over 1. So that means we can multiply 1 times 5, that is 5 over 4 times 1, which is 4. Whatever that we're going to get, we add to 13 over 8. So this is paper 2, guys. You can use your calculator to add as long as these stages are properly indicated. You can use your calculator. You're going to obtain 23 over 8, which is going to give us 2, 8 into 23, that's 2, remainder 7 over 8. So that is what you're going to have at the end. So make sure that you simplify your answer in simplest form. Okay, so that was our item 2. Item B of number 1, we asked to remove the brackets and simplify. So this is part that we are here given. We have to remove the brackets there and simplify. So what are we supposed to do? Okay, so we are just going to have our question as it was. So remember the question that we had advantage. I have a hard copy, so I'm just going to take from our hard copy. This is B. So we are given A plus 2 into A minus 3 minus 3 into A minus 5. So they were asked to expand the brackets and to simplify further. So let us expand the brackets for the first part here that we are given. So what is happening with A and A here, which is A squared, A times A, that's A squared, A times minus 3, that's minus 3A. So we're done with the first A. We move on to 2. This is 2 times A here, which is plus 2A, 2 times minus 3, which is negative 6. We're done with this part. Then we move on to this part here, which is being expanded by negative 3. So it's negative 3 that is going to expand this bracket. So it's negative 3 and A, which is negative 3A, negative 3 times negative 5. This is going to give us a positive 15. Okay, so from this case, what are we going to do? We have to collect like terms. In this case, all right, we have to collect like terms. So which are the like terms? Let's start. The A squared is nothing, so we just have to rewrite as it is. Then we move on to the A. We've got negative 3A plus 2A minus 3. So what are we simply doing? We are simplifying negative 3 plus 2 minus 3 like this. So we are going to obtain negative 4 from this part, all right? So that's negative 4 from your calculator. Negative 4 plus 15. So remember the person was 4. Asked to expand the bracket, so we put 15 and negative 6 here. So it's 15 minus 6 here, 15 and minus 6 is what we're having. So we put A squared minus 4A, 15 minus 6, that's plus 9. Okay, so that was it. After that, you are not factorizing anything. So the question was for you to remove the brackets and to simplify further. So that is what we had. Let us just cross-check the other part. So take note here, remove the brackets and simplify. That's it. Then the C part, giving your answer in standard form. So take note, your answer is supposed to remain in standard form, and you're asked to calculate 25% of that value that you are given. So if this answer is actually needed in standard form, what am I going to do? I can just make sure it's either I have to convert this 25% to standard form or do the other way. Okay, so let's see. I'm just going to have my question here. All right, so let's just save a space here. So this is item C. This is item C. We've got 25% off, which is multiplied by off means you're multiplying. So it's multiplied by 3,168 multiplied by 10 to the power of negative 4. Okay, so that was the question. Now in standard form, let us just first work with the 25% here. This 25%, we know that we can express this as a decimal. 25% to remove percentage, you divide by 100, which is going to be 100 into 25. That's simply, you are moving 2 commas to the left, which is going to be 1, 2. So it's going to be 0,25. Okay, so we put 0,25 multiplied by 3,168 multiplied by 10 to the exponent of negative 4. So this is what you're having in this case. So what am I going to do? I have to multiply these two numbers together, and now these numbers, because we do not have exponents of this, we just have to multiply them direct. So if I multiply this, I'm going to obtain something like 0,7, something like that. Make sure that you use your calculator. You're going to obtain 0,92 times 10 to the power of minus 4. So this is what you're going to have. Just multiply these numbers. But is this answer in standard form? No, it's not in standard form. Why? If we are to cross-check this, number is not between 1 and 10, it's 0, so it have to be between 1 and 10. That's here, you just have to move 1 comma so that it becomes 7,92 like this. Now it's between 1 and 10. But when we move this comma, we're trying to express this in standard form. So it would be times 10 to the power of minus 1, power of minus 1 here times 10 to the power of minus 4, which was already there. Because remember, we already had the minus 4. So that is your new question now that you're now having, and you can't give your answer like this because these two here, your multiplying bases which are the same. So what are you going to do? You have to add the exponents and plus and minus. That's a minus, so it's minus 1 minus 4, which is negative 5. So this is going to give us negative 5. So it's 2 times 10 to the power of minus 5, like this. your answer is now in standard form. Okay, so that was the case, guys. Just expressing in standard form. So it's a matter of playing around with the questions that should be given. Make sure that you understand exactly what you're given. Okay, then let's see the D part here. We have got a certain figure that we're given and parallel lines and so forth. We are given that A, Px and B, Qy, in this case, they are parallel lines. Okay, as you can see, these two, they are parallel, and AQ. Take note about AQ. This line AQ here is a bisector of PQR. So PQB, so this is PQB like this, and this is an angle. So it's a bisector of an angle. So what does it mean? It means this line AQ divides this angle B here, which is P here, to Q to B, this angle into two equal parts. So these two angles are equal. This angle here and this angle here at Q will be divided into two equal parts. That is what it means. So that is what we actually had. And the question is given that PAQ is 31 degrees. Calculate APQ, okay, which is our APQ, that is APQ, this angle here. This is the angle that we're supposed to calculate. All right, so that's our APQ. So what are we going to have at the end? I just want us to see something here. Since we've got our parallel lines, we are creating a Z here. We can actually find this angle here, which is Q, the Q here, which is A, QB, which is that one. If this angle is that one, it means also this angle is that one from the Z angle concept. But we said previously that these two angles, they are the same. So it means this also is 31 degrees. Okay, so that makes us easier. This makes it easier for us to calculate this angle at P. Why? Because we know that angles in a triangle, they actually add up to 180 degrees. So APQ, which is the angle that we are supposed to calculate, is going to be 180 minus these two angles, which are inside the triangle, which is that one plus that one. So it's going to be 180 degrees minus 62. And if we subtract properly, you're going to obtain 118 degrees from your calculator. All right, so actually that was the case. From this one, what were you supposed to do was to find this angle. So that is what we had. So this is going to be 118 degrees. So that is what we actually had. I think it was actually clear, this question. Okay, let's move on to the other part of the question. On 2A, we are given to solve the following equations. Okay, so you have to check the type of equation that you're given. The first one, these are just linear equations where you just need to collect like terms, you're done. So that's it, guys. Let us collect our like terms. You've got 0,3x and minus 0,4x. I'm going to transpose the minus 0,4 to the left-hand side. So it's going to be 0,3x plus 0,4x because it was a negative. So it's going to change its sign into a positive, okay? Already on the right-hand side, I put 1,8. So this is equal to 1,8. Transpose the negative 1,7 to the right-hand side. So it was a negative. Yes, so it's going to be a positive 1,7. So that's what I'm going to have at the end. So from this part, what are we going to do? Collect like terms, then you can add. That's 0,3 plus 0,4. That's 0,7x from your calculator. 1,8 plus 1,7 from your calculator. This is going to give you 3,5. So you can divide by 0,7 to remove x by 0,7 both sides. So therefore, your x in this case is going to be, guys, this is paper 2. No need for you to show us that you're going to multiply by 10 over 10. That one you do it when you're doing paper 1. Divide on your calculator, 3,5 divide by 0,7. You're going to get 5. So that is the advantage of paper 2. Some of the things, use your calculator. You're not like forced to say you're supposed to do the longer way there. No, guys. You have to apply your calculator where it is necessary. Please use your calculator, okay? Then the second part, which is a 3x, you're asked again to solve. So I'm just going to rewrite it here. This is our second part. That is item 2. So we were given 3x is equal to negative 64 to the exponent of third. A third, so that's what we have. So I'm just going to rewrite 3x is equivalent to negative 64 to the exponent of a third, like this. All right, so we have to apply our laws of indices first here on this negative 64. Remember, x to the exponent of 1 over a means the 8th root of what? Of x. So that is what it means. So in this case, we are going to have 3x is equivalent to Here we've got the cube root of negative 64. So it's going to be the cube root. Remember, the 3 is your a, and it's now in the root sign. So it's the cube root of negative 64, everything that you get to the exponent of 1. So 3x is equivalent to, what is the cube root of negative 64? A number that multiplies itself 3 times, and it gives us negative 64. So the number here is negative 4. So if you multiply negative 4 3 times, it is going to give you negative 64. So to find x, divide, because you're multiplying. So divide by 3 both sides, you're going to obtain minus 4 over 3, which is same as minus 1 and a third. We divide 3 into 4, that is 1, and got remainder of 1 over 3, and it's a negative. So that was actually the case of this one. I think it was actually direct. Okay, so let's try to see the other part. No, I do not need this for the meantime. I need this one. Okay, so let's just hope it is not going to take us to the browser. Okay. B factorized completely 6m squared n squared minus 6 minus mn minus 15. Okay, so this one you have to apply the longer way of factorization. So this is B. We've got a 6m squared n squared minus mn minus 15. So what I'm going to do in this case, remember the longer way of your factorization, where you need to multiply the first term and the last term. Since here the coefficient of the first term is not 1, so you have to apply the longer way. So if you multiply 6 and negative 15, you're going to obtain negative 90 m squared n squared. So what are you going to do? Ask yourself here, what are the factors of negative 90 m squared n squared? But when you add this, they must give you the middle term, which is minus 1 mn. Remember, this is your n, so it must give you minus 1 mn. So which are the factors of negative 90? So it's a trial and error concept where you need to try the numbers that you multiply those numbers. If you multiply them, they must give you negative 90. But if you add them, they must give you negative 1. So here I got these two numbers, which is negative 10 and 9. Okay, if I multiply these two, I get negative 90. If I add these two, I get negative 1. But since here is mn, so it must be minus 10 mn 9 mn. That is what it means. Okay, so these are the two numbers that I'm going to substitute into the middle term. And what is the middle term? That is minus 1 mn. So that means the question is going to look like this: 6 m squared n squared. We now substitute into the middle term. So we're going to substitute these two numbers now, which is minus 10 mn plus 9 mn minus 15. Okay, so that's what you're going to have. Now divide this into 2 like this. If you are to divide this into 2, that means we can factor out for the first two terms, 6 and 10. Here 2 is common, that is our highest common factor, 2. We move on to m squared, and m here, highest common factor is m, n squared, and n, highest common factor is n. Remember, if the letters are repeating like this, you take the one that has got the smallest exponent. So it's m and n, the one that is got smallest exponent. Okay, after this we have to divide 6, divide by 2, that is 3, m squared divide by m, that is m, n squared divide by n, that is n. So that is it on the first part. Minus 10 divided by 2, which is 5, m and n, m and they will cancel here, so it's going to be 1, so it's just 3mn minus 5. We do the same on these two terms which are remaining. And if you have to cross check, here is 3, which is common. We've got 9 and 15, so it's plus 3, which is common. We do not have mn here, so it's just 3. So 9 divided by 3, that is 3mn. Minus 15 divided by this 3 is negative 5. So as you can see, guys, these two brackets are the same now. So I told you that once these two brackets are the same, what are you going to do? You factor out that common bracket, which is 3mn minus 5. Then what is remaining is 2mn plus 3. You put that one in a bracket. So that's what you're going to have at the end. So you factorized the whole expression. That is going to be our resultant or our answer in this case. Okay, so these are the typical questions, guys, that you're supposed to work with. Okay, the C part, express as a single fraction in its simplest form. Okay, so this is the fraction that we're given. We want to express this as a single fraction. Okay, so I'm just going to rewrite it here. So this was our item C. Okay, if I'm not mistaken here, that's our item C. Okay, so let us take down the question is x minus 4. Here, I'm just going to factorize here the first one. So it's x minus 4 over 16 minus x squared. This is difference of two squares, remember, so it's going to be square root of 16, which is 4, square root of x squared, which is x. So one bracket will add, and remember, another bracket will subtract, so it's 4 minus x. Okay, we are dividing here, so what are we going to do? We introduce multiplication on this part, that is dividing, and we invert the second fraction. So we're going to introduce multiplication. If we invert, this is going to be x plus 4 on top, x plus 4, and the 2 now in the bottom like this. Okay, so that's it, guys. We can now cancel if they are like terms. So this is x plus 4, 4 plus x. These are just the same. This one is just same as x plus 4 here, just like 1 plus 2 and 2 plus 1 is just one and the same thing. So these two can cancel. But I want you to see that this cannot cancel here. This x minus 4 and the 4 minus x, for the meantime, they cannot cancel. So this is what you're going to have. We are going to have our answer as x minus 4 over 2 into 4 minus x. But there's something that is very, very common about these two terms which cannot cancel. What is it common? What is the common part? Remember, guys, I told you that once the numbers are the same, like this one, we have got x here, we have got 4 and 4, but the difference is that this is positive x, this is negative x. This is negative 4, this is positive 4. On a quotient like that, you simply factor out a negative in the numerator there, so that these two brackets will be the same. All right, so you just factor out, even in the denominator, wherever you're going to factor out your negative. Okay, so if I factor out a negative like this, it means these two brackets will be the same. So since I factored on the numerator, so it means this x minus 4 will be the same as 4 minus x, like this. Okay, everything over 2 into 4 minus x. I affected the numerator. If you wanted the denominator, it means it was going to look like this. Let's say you chose to work with the denominator, therefore it was going to look like this. The numerator was going to remain as it is, x minus 4 over. In the denominator, you want it to look like x minus 4, exactly like x minus 4. So you simply factor out a negative here. So that means we're going to have something like negative 2 into. The moment you factor out this negative, these two are the same. So it is going to be x minus 4. So you can cancel now x minus 4 and this. This will be 1, so it will be negative 1 over 2. So it's just the same thing even here. We just have to cancel these two brackets. 4 minus x, 4 minus x, we put 1 and 1, so it's going to be negative 1 over 2. So as you can see, you're obtaining the same answer here. So you choose which part do you want to work with. As long as these two are similar to each other, the only difference is on the signs. That is what you simply do. You factor out a negative from one of the brackets, then it becomes the same as the other bracket. So please take note about this typical question, because actually, yeah, they do ask this type of a question. I think I've explained this from previous question papers. You can even relate from what we did before. Okay, so that was it. Then let us move on to the other part of the paper, which is the question 3. We are given a Venn diagram. This is the information that we are given, the number. The Venn diagram shows some information, which means the other information is not there, because we are given some of the information. The other is not there, so you have to fill in about all the 52 families. So this is the universal set, which means we've got 52 in the universal set. Then in a village, C is a set of 37 families. So this C that we see here is for 37. We have got what? We have got cattle. So here we've got 37 elements. We move on to G is a set of 24 families that have got goats. Okay, so this is G that has got 24 families. And S is a set of 20 families that have sheep. So this is a 20 here. Okay, so here I'm just indicating to say the whole of this set is 20. The whole of this set is 24. The whole of this set is 37. All right, so that was the question. That was the information, not the question. Okay, then it is also given that 14 families have cattle and goat. Okay, 14 families have cattle. Take note, they have cattle and goat. So we need where there is C and G. Okay, so where is our C and G here? C and G here in between. So there's 14 here. So that is why you see here it was 14 minus x, because the whole of this set is 14. So it's 14 minus x, which is that part which is already filled. which is the same thing here that we are given. This one is x, and all three which are got 11. We've got cattle, which is the same 11 here, cattle and sheep, and x. We have got no animals at all, which is this one, which is outside of the set. These ones, they do not have any cattle, they do not have any goat or any sheep. This is this x here. So as you can see, this number x here is the same as this x for those who have got all the three. Okay, so that was the case. So let us see the first question of what you're given. Find in terms of x. Okay, the number of families with cattle only, goats only, sheep only. Okay, so that is the first part that you're given. So how do we attempt these typical questions, guys? We need cattle only. So let's get back to our diagram and see. Cattle only, that is this part here. Okay, let me just see if the indicator is not there. Okay, let me just use the mark. So this is your cattle only, which means you are referring to this region here. This is your cattle only. This is goat only, and this is sheep only. Okay, so how do we find now the ones with the cattle only? That was the first item of the question. We need the ones that have got cattle only. All right, so this is what you're going to do. Since we said those who have got cattle, all of them, they are 37. And we are given this part that it was, remember, this is the set for cattle. This one, I'm just going to re-indicate this one. This is the set indicating those with cattle, this one. Everything in this set. So which means you are going to subtract all these elements from 37 so that we can get this remaining part, okay? So that is what you're simply going to do, okay? So you're going to say out of 37 elements, out of 37 families, we subtract all the other families that we are given. And which families we have? We've got this one of 14 minus x. So we're going to subtract the family of 14 minus x. This one, these families of x, and these with 12 minus x. So you subtract everything that is surrounding the set for C, so that you remain with C only. Okay, so that was the case with this consideration. So that is it, guys. 37 minus open, work with the brackets first, is 14 plus 12 here, which is 26, minus x plus x, that's a 0 here, same as minus 1 plus 1, that's a 0. Okay, so you're going to remain with this negative x. Okay, so expand the brackets. It's going to be 37 minus times 26, which is negative 26. Negative times negative x, that's going to be positive x. So you can collect like terms. That's 37 minus 26, which is 11 plus x, or you can write it as x plus 11. I don't know what was best for you. Okay, so that is what we have got here. So it's 11 plus x, or x plus 11. So that is cattle only. Then the second part is goats only. Here we need goats only. So let's see, goats only. Still, we have to do the same thing just like the previous part, guys. All right, so we need goats only. So this is just item 2. So we need goats only here. Okay, so let's cross-check the set for G here. So this is goats only. So G, it has got 24. So you subtract everything in G, just like what we did previously. So what are you going to subtract? We are going to subtract 14 minus x, x, and 11 minus x from this 24. Okay, so that was the case. So let us subtract everything from 24, which is the set of everything. So it's 24 minus the part that is what we do not need, which is 14 minus x. Okay, so we've got 14 minus x plus x, and we are going to remain with this part of 11 minus x. So these are the elements that we are going to remove, 11 minus x. So just like the previous case or the previous question, what are you going to do? We have to expand inside the bracket. So we're going to obtain 24 minus 14 plus 11, that's 25. So this is going to give us 25. Negative x plus x, that's a 0 here. We're going to remain with this negative x, so it's negative x. Expand your brackets, is 25, is 24 here. Okay, so this is going to give us 24 minus times 25, which is negative 25. Negative times negative x, that's plus x. So that's what you're going to have at the end. So you can actually subtract here. 24 minus 25, that's negative 1. So it's negative 1 plus x. Or you can write it as x minus 1. Still it's fine, just like that. Still one and the same thing. So it's x minus 1 or minus 1 plus x. So this is our x minus 1 here. Okay, then the other part is sheep only, which is sheep only here. So let us put it, we can even write it here. So this is sheep only, which was item 3. Okay, so sheep only. So you have to do the same thing, just like what we did. This part sheep, everything for sheep is 20. So you're going to subtract all these 12 minus x, 11 minus x from this 20. Okay, so that's what you're going to do in this case. So it's 20 minus everything in this set for sheep, which is 12 minus x. So we're going to remove 12 minus x plus this x for everything plus this 11 minus x. So you subtract everything that is surrounding this set for s. This is the set for s. What is surrounding this set is the one that you remove. Okay, so as you can see, just like the previous part, guys, it's our element of us to simplify as much as you can. It's going to be 20 minus 12 plus 11 here, that's 23. That is going to give us 23 minus x plus x, that's a 0 here. So we're going to remain with this negative x. So it's negative x. Expand the brackets. That's 20 minus times 23, which is negative 23, minus times minus, which is plus x. So 20 minus 23 from a calculator, this is negative 3 plus x, or x minus 3. So this is a sheep only, which is x minus 3. So you can just going to indicate on the diagram, you never know. We might need this information. So this is x minus what? X minus 3. So that is what we had, guys, from this diagram. As you can see, it was just direct, right? So let's see the other part of the information. Find the value of x, which is the b. Find the value of x, then the number of families with goats, but no cat. Okay, so let's start by finding x. So how are you going to find x? To find x, we have to add everything, guys, that we are given here in this set. It must give us this 52. Remember, we said our universal set here, there are 52 elements. So if we add everything here, it must give us 52. So I'm just going to even do it here. Yes, it can actually find. So let us check what item do we have here. So this is item B, item 1. So this is B, item 1. All right, something of this nature. I think here it can work. So you've got B, item 1. So we need to find the value of x. So like I said, we are just going to take everything. Okay, let me just change here. So we're going to take everything. All right, so what are we taking here? We have to add everything and add to 360. So we're going to take this part, everything, guys. 11 minus x, 14 minus x. So make sure that you take everything in this set, including this x outside of the bracket, this one outside of these two, outside of these three sets. Okay, so make sure you take everything. So here we have got 11 plus x, we've got 11 plus x plus 14 minus x plus x plus 12 minus x. Okay, plus x minus 1. I hope everything is going to be there. Plus 11 minus x plus x minus 3. Okay, plus x. So I think that's all we had there. So you have to equate to 52. So what I've done, I've taken everything in these sets that we have. Okay, so that's it, guys. We have to take everything. Then you add the numbers together. Here, so we're going to have 11 plus 14 plus 12 minus 1 plus 11 minus 3. So this part, you're not doing anything. It's your calculator that is going to simplify this for you. So you're going to obtain 44. Okay, then you move on to x. Here, I want you to see x minus x, that's a 0 here, so you've cancelled. X minus x, that's a 0, you've cancelled. X minus x, that's a 0, you've cancelled. So we are going to remain with this only x that we have. So it's going to be plus x is equivalent to 52. So to find x, transpose the 44 to the other side of the equation. That means our x is going to be 52 minus 44. Okay, so 52 minus 44. Okay, guys, I think there's another part that I actually left here. This x here. Okay, I'm seeing this x. I didn't include this x here. Yeah, this x. So this x here, because remember I said x and x, that's a 0 here. x and x, that's a 0 here, x and x, that's a 0. So we left this one, so it's this x and this x here, which is going to give us actually 2x. So this is 2x. So 2x is equivalent to 52 minus 44, which is 8. So we can divide by 2 both sides. We can divide by 2 both sides. So our x is going to be equal to 4. 2 into 8, that is what? That is 4 in this case. So that's how you simply work out this. So it's just actually very simple, guys. As you can see, it's a matter of playing around with the questions. As you can see, it's actually nothing. So that was the value of x. Then let's see the other part. What are we given here? Since we now have our x, the number of families on B item 2, the number of families with both but have no kettle. Okay, they have got these guys, but they do not have kettle. Okay, so which part actually on the diagram is that is this? They have gods, but they do not have kettle. Okay, so this is what you're going to do, guys. This is the set for gods. This one, as you can see, this is your god here. But these ones, they do not have kettle. So what are we simply doing? We are simply removing the part of kettle. Remember what I did previously? I indicated you to say this is the set for kettle, this one. So you are removing this part from what? From your god. Okay, this is the set for gods that you are just removing from. So this is the kettle, this one that I've indicated, this one is for kettle, this one. So you are removing this part from the gods. Remember, the god was supposed to be like this. It was supposed to be the whole set like this one. But now you are no longer taking it inside because this part is good kettle. So you are now working with this part alone. So this is the part that you are taking because we do not need kettle. Yes, they can have goats, then also they can have sheep. It's fine. What we do not need is this part of kettle here. So which means we are going to remain with this 11 minus x and this x minus 1. So this is the part that we need. Okay, so this is our B item 2. So as you saw that we are remaining with 11 minus x and x minus 1 plus x minus 1. But remember, we got our x, and even if we have our x, these two guys, they're just going to cancel each other. Whether we know that our x is 4 or what that we have is not going to actually work because that x is the same. So 11 minus 1, that is 10. So which means we are going to remain with 10. Now what I'm trying to say is that, remember our x was 4. So even if I substitute that x here, which is 4, it is not going to work, guys. Like minus 4 plus 4, that's a 0. So this part cancels. So it's just going to remain with 11 minus 1, which is 10. So these are the number of people that he had what? Gods, but they do not have cattle. So that was the case here. So you see, guys, your sets. So that was your set, guys. The first part was 6 marks, and the other one was 4 marks, which means 10 marks just for sets. Just imagine, guys, you have to revise. You have to revise as much as you can because these are a lot of marks that you are seeing here. There are a lot of marks. Okay. Then on number 4, we are given in the diagram, there are 3 points, PQR are 3 points on level ground, PQ 20 meters, PR 30 meters, and we are given the value of cos RPQ, okay? So this is cos RPQ, which is the cosine of this angle, RPQ, which is the cos of this angle here, okay? So we're given the cos of this angle. Then the question is calculate. Okay, so let's see if we are to write it here. Okay, so this is our A. We are saying cos RPQ here. So RPQ is equal to negative 1 over 3. So to remove this here is going to be like this. RPQ, which is the angle that you want to calculate. So like I said, it's going to be shift or second function of your calculator and make sure that is what in degrees. If you have to do this, you're going to obtain 109, 471 something like that, 4712206. So you have to write everything. Then this is an angle. Remember, your angle is supposed to be rounded off to 1 decimal place according to the instruction. So this is 109 comma to 1 decimal place. This 7 is going to change this into 5, so it will be 109 degrees, 109 comma. So it's 109.5 degrees, which is this angle here. Okay, so that was it, guys, for you to calculate what? Calculate RPQ. So now you have this angle. And the next question is to calculate the length of QR. Okay, this is the length of QR. Okay, so what are we supposed to have? actual sense. I want us to see this length QR here. If we are to check on our diagram, this is our QR here, this is QR. If we are to cross check, actually guys, this is what was supposed to happen because we are given this, there's an angle, and remember you're given the cosine of this angle here. So you've got two sides and third angles, and the third side that we need to calculate, and these are actually included. There's an included angle here, and you want to calculate the third side, which means we can apply your cosine rule. So what does the cosine rule actually state about calculating a side? All right, so this is B. Remember, cosine rule to calculate a side is a squared is equal to b squared plus c squared minus 2bc cos of what? Cos of a. Whereby b and c, these are the sides which are creating the angle. In this case, we put these sides, which is 20 and 30. So these are the ones that you're going to use. So we are going to have 20 squared plus 30 squared minus, as you can see, b and c, those are those sides that you are simply repeating. So it's 2 times 20 times 30, you are multiplying times cos of a. But in this case, we are referring to the cosine of this angle, which is RPQ, the one that we had. So I'm just going to write it the way that it is written there. So this is cos of RPQ. And remember, you are given this cos. So there was no need for us to write it like this. We're supposed to just simplify and substitute that cos RPQ that we are given. Okay, so let us substitute it on this stage. 20 squared, that is 400 plus 30 squared, which is 900, minus you multiply 2 times 20 times 30. Make sure you multiply properly. You're going to obtain 1,200. Multiply by cos RPQ now, which is the one that we were given here. Remember, cos RPQ are already, instead of you using this angle that you calculated, use the one that you're already given, which is minus 1/3. Okay, so we are going to multiply here by negative 1/3. So that's it. We can add 400 plus 900, which is 1,300. If I'm not mistaken, that's 1,300 plus. Why a plus? Because we've got a negative here and a negative. So if these two multiplies, they give us a positive. So on your calculator, multiply 1,200 times 1/3, which is a third. So you're going to obtain 400 in this case. Okay, so you can add, which is 1,700. But this is the a squared, which is representing our a here, which is the side QR. So here we're supposed to write it as QR here. So it's supposed to be like this. So this is QR squared. So which means this is an expression, or this number here represents QR squared. So how are you going to find the QR? Introduce the square root to remove this square here. So that means we are going to remain with the QR. So QR is the square root of 1,700, which is going to give us 41, if you are to simplify this, is going to give us 41,231, something like that, up to the last digit. So QR is equal to, you round off to 3 significant figures, because this is a side. You remember you're dealing with sides. So sides, you round off to 3 significant figures. That's 1, 2, 3. So this number here is smaller than 5, so it cannot round off these 2. So it is going to remain as 41,2 meters. So remember the units. Use the units that you have got here. This is 20 meters, 30 meters, so which means these units are in meters. So now we have got our QR here, which is 41,2. So we can even indicate it on the diagram here. We now have this one. We say it is 41,2 meters. Okay, so that's our QR here. And let's see the other question. Calculate PRQ. This is PRQ, which is item C. Okay, so this is item C. We are supposed to calculate PRQ. Okay, so that is it. We have to indicate this angle here, P here to R to Q, which is this angle here. So on this one, we can even apply our sine rule. Yes, we can apply cos if you want, but you can actually apply sine rule since we need an angle and we've got an opposite side, and here we've got an angle and an opposite side. So which means we can apply our sine rule or cosine rule depending with what you actually need to use in this case. Okay, if it is cos, it's fine. If it is sine, it's also fine. So in this case, I'm just going to prefer sine, but just choose any of your choice. Okay, so this is our item C. So using sine rule, remember sine, calculating an angle is sine A over A is equal to sine B over B. So you just need these two. So it's sine of the angle that you want to calculate here, which is sine PRQ. So it's going to be sine PRQ over the corresponding side, which is 20. So it's over 20 is equal to sine of this angle that we calculated. Remember, we got 109.5 degrees over the corresponding side here, which is 41.2. So you just use any method that is familiar to you, that you are used to. So how are we going to find this angle? Okay, so this is what you're going to do. For us to remove this 20, you can simply multiply by 20 here, multiply by 20 on this side. Okay, so if we do this, guys, what are we going to have at the end? This can cancel each other. That means we are going to remain with the sine PRQ. So this is sine PRQ, guys. Okay, so this is PRQ like this, which is equal to this is just same as 20 over 1. So you can multiply 20 to this sign, which is 20 sine. Okay, so let me just put back to the right. So since you are multiplying, make sure that you do not simplify that sign 1 or 109.5. No, just multiply it like that. Don't simplify anything. So it's going to be 20 sine 109.5 degrees, everything over 41.2 like this. Okay, so you can write this as a decimal. That is sine PRQ is equivalent to. So actually, it's best for you to use the exact answers that you got. But writing these answers, it means it doesn't mean that your answer is wrong. No, your answer is right. But it is best for you to use the exact answers that you got previously. But if you didn't manage to store those values, work with the one that you are given as it is. This one, the rounded figure, is fine like that. Okay, so this is what you're going to have as a decimal. You're going to obtain something like 0.47457 5, and so on and so on and so on. So just like what we had here, cos RPQ is equal to this. How did we find RPQ? We ended up finding arc cos. So the same thing here. We have got sine here, so it is going to be arc sine. So to find PRQ, it is going to be arc sine, not arc cos, but arc sine. Since we are dealing with sines, it is going to be arc sine 0.4575 and so on, the one that we get. So that is going to give us our PRQ. Okay, so that is it, guys. PRQ is going to give us 27.23 and so on and so on and so on, which is going to give us 27.2 degrees. Okay, so that is the angle that we are going to obtain on PRQ, which is 27 degrees. Okay, so that was it on this part. Let's move on to the D. The three-figure bearing, take note, the type of bearing we are told is three-figure bearing, and we know this one is taken from the north in a clockwise direction. So we need the three-figure bearing of Q from P to the nearest, correct, to the nearest degree. Okay, so we need the bearing of Q from P. Okay, so that is Q from P. Let us just cross-check from our diagram what exactly do we need here. So this is a Q from P. Okay, so this is what is going to look like, Q from P. Okay, so that is what we need here from P. This is the P, the north of P. So we need from this P going to this line, which goes to Q like this. So this is the angle that we actually need. All right. So what are we going to do to find this angle here of Q from P? If we are to cross-check here, we know that this is a straight line. All right, we know this is a straight line here. So we've got 180 degrees for a straight line so far. So we've got 180 degrees, but there is this angle that is remaining in between these two lines, this one that is remaining. Yes, we have got this angle inside the triangle, which is we're supposed to take, but we do not have this angle in between because we're supposed to add this angle also. So where are we going to get this one? We are going to get it from R here. Why? Remember, we are told that this is a north pole that we have, so which means these two lines, they are north poles and they are parallel lines, so which means they do not meet these two lines. So if they are parallel lines, we are creating a Z here. We are creating a Z, as we can see. So it means that angle that we got on R here, that 27.2, remember we got 27.2 previously here, so it's going to be 27.2, and also this will be 27.2 from the Z angle concept. So this is 27.2 degrees. So that means to find this bearing, which is our D. So this is D, which is Q from P. So we are going to add these angles. We said we are going to add 180 degrees plus 27,2 degrees plus 109. We are going to add also 109,5 so that everything is involved from this part. Okay, so that's it. If we add everything, we're going to obtain 316,7 degrees. But remember, this is three-figure bearing. That is why we are told to give this answer to the nearest degree. So the nearest degree means to the nearest whole number. So we are going to round off this answer here to the nearest whole number. So that is, we have to cross-check the 316 here. This 7 that follows is bigger than 5, so it can round off this 6 into 7. So it is going to be 317 degrees. Okay, so that was the bearing of Q from P, correct? To the nearest what? To the nearest whole number. So that was the case, guys, in this question. So as you can see, that's your solving triangles in conjunction with bearing. And yeah, that's what we actually need. And it is a lot of marks. Guys, we just need to revise as much as we can. As you can see, these questions, they actually do need revision. You have to find time to revise as much as you can. All right, so let's move on to the other part. On number 5, we are given in the diagram A, B, C, D is a cyclic quadrilateral. Okay, so this is a cyclic quadrilateral. TA is a tangent to the circle at A and is parallel to AB. So this tangent is parallel to DB, this DB, so these two, they're parallel. So as you can note, let us indicate some of the things while we still have this idea. So we have got a Z here, so it means this angle at D is going to be 51 degrees. Okay, from the parallel lines, just from the parallel lines. And also this is a circle, guys. You can as well just continue here with your circle, okay, so that you just complete, so that you properly see what is happening here. So if this is a chord, it means this DC is a chord, so this angle at B and this angle at A, they will be the same angles created by the same chord on the circumference. They are the same. Also, if you are to see here from this chord, BC is creating an angle here at D. So the angle at D and the angle at A, they are the same. If you are to cross-check from the chord AD, this chord AD is creating angle here at B. Also, AD is creating angle at C. So it means this angle at C is the same. And we've got the vertically opposite angles here on P. This is 78 at P. It means also this is 78 on this part here of P. So this angle here is also 78 degrees, just like what we're given. All right, let me just try and write it properly so that we see this one. So we say this one is also 78 degrees at P. This one that is opposite, these vertical opposite angles. And also these ones, they are also the same, also opposite angles. Okay. So that was the information, guys. And we are given that TAB is 51 degrees, a PD is 78 degrees. This one, calculate a CD. That is the first question, item 1, a CD. Okay, so let's cross-check where our ACD is located. So this is A to C to D, this angle here. Okay, so where are we going to have this angle, which is our ACD? All right, so if we are to check what we have with this angle, we've got a tangent. Remember, from our circle geometry, as I talked about the issue of a tangent, that angle between a tangent and a chord is equal to the angle in the opposite segment. So this angle here is between a tangent and the chord creates the angle at the circumference. So these two, they are the same. So you've got 51 degrees here. So it means also this is 51 degrees. Okay, so you can take that advantage. So this was our BCA. Okay, so this was ACD. Okay, so this is 5A item 1. Okay, so it's ACD is equal to 51 degrees. Okay, so that is it from a tangent and a chord part. So this you can just write in short, tan chord, angle between a tangent and a chord. Okay, then we move on to the other part. Let's see what you're given. That is BAC. Okay, so we need BAC. That's here. B A to C, this angle here. Okay, so how are you going to find angle BAC? So it's a matter of playing around with the persons, guys, for us to have that BAC. Okay, so actually we have a lot of things that we had in this case that we actually need to have this BAC. Okay, this is what I'm going to show you. I want you to see something. Remember, we said these two angles are the same. This 51, this one in black. Remember, I indicated this one in black, this one in black here, this angle and this angle. Remember, I said they are the same. So this is 51. So you can even write this is 51. And these are angles on a straight line. So you can find this angle on P, which is the same as this angle on P here from angles on a straight line. So we can subtract 180 degrees minus 78 degrees, which is 1 or 2, if I'm not mistaken. That's 102 degrees. So this is 102 degrees. This is also 102 degrees at P here. So at P, this angle is 102. Okay, so take note, guys, this angle at P, we said is 102 degrees. So to find this angle that is remaining at A, this one that is remaining at A, which is our BAC. So we can even write it down, BAC, this is item 2, so we need BAC. We are going to subtract from 180 degrees these two angles, this one at B, which is 51 degrees, and this one at P, this one that we had of 100, which is the same as this one, which is 102 degrees. Okay, so you can subtract these two angles. That's 180 minus 51 plus 102. That's going to be 153 degrees. So it's 153 degrees. So if we subtract 180 minus 153, that would be 27 degrees. Okay, so this is 27 degrees here. And we say this angle at A is the same as this angle at D. So it means also this is 27 degrees. Remember, I indicated this previously, guys, that these two are the same and so on and so on and so on. Okay, so that was it. It's just a matter of your theorems and your triangles. Okay, item 3, BCA. So we need BCA now, B to C to A. Okay, so this is the case here. Okay, let's just choose another one this time. Okay, so he said BCA, which is this one. Okay, so this is your BCA here. And this BCA here is the same. If we are to cross-check from chord AB, this one, from this chord AB, AB is a chord. It's creating angle here at D. Here, it's creating an angle at D. I want you to see it's creating this angle at D here, and also creating this one. So these two angles, they are the same. So this is also 51 degrees, just as this one, it is also 51 degrees from what? From the same chord. So these are angles created by the same chord. So it was not actually nothing here, guys. Okay, so this was the item that is BCA. So BCA is going to be 51 degrees from what? Angles of the same chord. Which is what is that code that we had. So I think it was actually direct, this one. Okay. Now the other part is to write down the reason why a triangle APD is an isosceles. Okay. So for a triangle to be an isosceles, remember it must have this condition. It's either two sides are the same, or it's either there are two angles here the same. One of these makes the triangle to be an isosceles. So that's what we have to check from triangle APD. So let's get back to our triangle and locate AP to D. Okay, so this is triangle A here. P, remember your P is the one that we covered up here. This was our P and this was D. Okay, so what are we supposed to do? As you can see, we do not have this angle here that is remaining at A. So we have to calculate this angle at A. So that we will be sure that truly these two must be the same. So we have to calculate that angle at what? At A, so that we actually we verify everything. Okay, so that's what we are going to have here. So let us calculate this angle at A, which is DAP. It can help us. So DAP is equal to 180 degrees minus, remember we've got 51 and 78. So we're going to add 51 degrees plus 78 degrees. So if we are to subtract these two, we are going to obtain 51 degrees. Okay, so that's what you're going to obtain. So it means this angle is 51 degrees. Or you could have just, I don't know, you just cross check, guys, if there was any other way. that was easier for you to have that angle. So as you can see, these two angles are the same. So definitely it becomes an isosceles triangle. Remember those two conditions that I showed you. It can be from two sides which are the same or two angles which are the same. So it makes an isosceles triangle. So the reason that we are having, we have got what base angles, two base angles are the same. Base angles are equal or the same. So if the base angles are equal in a triangle, it makes it to be an isosceles triangle. Okay, then the third, the part C, calculate the length of AD. We are now calculating length. Now forget about psychogeometry, because psychogeometry does not deal about calculating length. You have to think about your solving triangles, understand your triangles and so forth. Okay, so let's get back to our diagram and see where our AD is located. Okay, so this is our triangle and this is our AD here. So to calculate AD, guys, there were actually so many ways that we could have done to calculate this AD. Okay, this is what we have. Remember, we said this is an isosceles triangle. So by default, it means, remember, this 51 is opposite to 5. This one is opposite to what? To 5. Let me do this. This 51 is opposite to 5. So this 51 also must be opposite to 5. So it means dp, remember this is your p here. So dp will be also 5 units. So this one is also 5. So it's an isosceles triangle. Okay, maybe this 5 does not help us. But if you could, like, we want to calculate AD. We had two options that we could have used to divide like this triangle here. Remember, if you divide an isosceles triangle like this, it gives us a right angle triangle. So you can use the concept of a right angle triangle, because this will be 5 here, and this will be 51. Okay, so this angle will be 51 degrees, and you want to calculate this side. So you calculate this side, you multiply it by 2 to calculate the whole of this side, of which it was going to take us some time to do that. Calculate this side, then you multiply by 2. So what I was going to do, I was just going to apply sine rule. Why sine rule? Because I need this side and it's opposite this angle here. The side and the angle, they're opposite, and also this is opposite and side, so which means we can apply sine rule. Okay, so what does the sine rule state of calculating the side? Remember your sine rule, guys, states that we can even write it here. So this is C, part C. So sine rule for calculating side is now A over sine A, which is equal to B over sine B. So the A is the side that you are calculating, which is AD. So it's AD over sine of the corresponding angle. So AD corresponds with what here? All right, so this is AD. It corresponds with this 78 here. So it's going to be over sine 78. All right, so this is going to be over sine 78 degrees, which is equal to B over sine B. That is any pair. So as you can see, these are the same. You can choose this 5 and this 51, or this 5, and as you can see, they are the same. So it's just one and the same thing. So it's 5 over sine 51. Side over sine of the angle. So the side there is 5 and the angle is 51. So it's sine 51 degrees. Okay, I do not need this 78, which is dividing. So how do I remove it? I multiply by 8. Since it is dividing, I have to multiply by 8, both sides. Remember, what I do on the left-hand side of the equation has to be done on the right-hand side. So which means I'm going to remain with AD by just doing this. So this one is same as like over 1. So it's 5 times this over 1, which is 5 sine 78 degrees over sine 51 degrees. So this one on your calculator, everything, do not think of anything here, use your calculator direct. You are going to obtain something like 6,2 93, something like that, 0 and 2, and so on and so on and so on. So you can round off to 3 significant figures, since this is length or it's a side, so it must be through 3SF. So it's 1, 2, 3, and as you can see, the next digit, which is 3, is less than 5, so it cannot change this one, so it will remain as 6,29. So this is 6,29, and the units cross-check on the other dimensions that you are given. Here we are given AP is 5 centimeters, so which means the units on this diagram, they are in what? Centimeters. So that is what it means. So it means here we are going to have our answer in centimeters. So take note of the units. It's much better for you not to write the units than for you to write wrong units, because if you write wrong units, it means everything is wrong. So make sure that you write the actual units or not to write the units at all. It's much better in exam, in your final exam. But for now, this is practice, guys. Just make sure that you practice everything perfect. Okay. Name in correct order the triangle which is similar to APD. Remember, guys, what I told you about similar figures. Similar figures, these are equiangular. They are taken according to equal angles because we are saying they are equiangular. So we need the angle equal to A, the angle equal to P, and the angle equal to D. So this triangle is similar to which triangle? So let's take APD. So we need triangle APD here. All right, so this is our triangle, guys, APD. Remember, this is our P here. Let me just put it here. This is your P. So we've got A, P, D. So you have to take this one according to these angles. They are the same. So I want you to see something that is happening here. Angle A here, we have got A, P to D. We have to take them according to equal angles. Okay, so I want you to see what is happening on this part here. This 51 that we have on C is the one that we indicated. If you still remember here, when I indicated here with this marker here on D, on this D here, if you still remember what I did, we say this angle at D, this one is the same as this 51. So this 51 at C is the same as the one at D. So I do not want you to confuse these ones. Okay, this 51 at C is this one at D from what? From the chord AB. Okay, then let me change so that it can be clear. Okay, let me choose this one. Okay, this 51 at A, I talked about it. This one at A is the same as this one. Remember this dot here in red I talked about before before you be introduced, where we said they are created by what? By chord DC. When I extended this line and I said this one at B is the same. So this is 51 at B, which is the same as this 51 at A. Okay, so do not confuse these two. Okay. And the 78 here, this 78 here is the same as this 78 at P because these are vertical opposite angles. Okay, so that means APD. This A here corresponds with what? With the B. This A, it corresponds with what? With the B. So this is your B here. So you're going to take B, that is, remember we said they are equiangular. You take them according to equal angles. So this is A. We said our A is same as what? Is same as B. We move on to P. P is same as P because those ones are vertical opposite angles here. This P and this P, 78 here, they are the same. So that P is the vertical opposite angle of the other P on the other. So this is P. Then we move on to D, and we say D is the same as what? D is same as C. These two, they are equal here, these ones, okay? So this one is C. So that is how you take similar figures. They are taken according to equal angles. So you do not just take to say this is angle 51, no, you take them how did you have that 51? That is how you are working with it. Okay, then the one that is congruent to ABP. So congruent figures, we are simply saying they are the same, like remember your cases of congruent, they must be actually directly equal. Okay, so let's cross check. This one is congruent to triangle. Let's cross check APB. Okay, so we need triangle APB here, which is this triangle A to P to B, from A to P to B. Okay, so I want you to see what is happening here for 27 to 102 to 51. This is what is happening on this triangle here. From this 27 to 102 to 51. Guys, I want you to see what is happening. I want you to see exactly what is happening here. Okay, let me choose something, maybe this one. This is A, P, B. From A here, we've got 27 here, which is this one, okay? To P, which is this one at 108, which is this P here. To B, this is your B, which is, so we are taking this direction from this D to P and back to C. It must be exactly the same as that triangle. So it's D, P, C. Okay, so that one is going to be congruent to triangle DPC. Okay, so this triangle and this triangle, they're congruent. So our answer there is triangle DPC. So congruent figures, guys, they are exactly the same, exactly the same. Okay, so that's what you need to know there. So we say that this one is going to be DCP. So similar figures, they are not exactly the same. They are just equal in terms of angles, not the diagram, to say the diagram, because I want you to see what is happening. Please take a closer look here. This triangle here and this triangle, they are not of same size, as you can see, but is the angles here. This is 51, this is 51. But look at triangle APD, it's a bigger triangle compared to this smaller one. It's a bigger triangle. But these two, they are exactly of the same size. Those are congruent figures. But you take them in the order that is the one that you're given in the condition. So it's a matter of playing around different types of questions, guys, so that you can truly understand this concept. Okay, but that's what we had. As you can see, guys, it was actually a lot of marks on this second geometry. It was actually a lot of marks. Okay, but anyways, that's what we had. Let's see the other part. All right, this one is a construction. So we are going to see this part of construction. How are we supposed to have our diagram so that it can actually help us to construct this diagram? Okay, so actually what I'm going to do is to have a sketch. Remember, guys, construction, all you need is a sketch. So I'm just going to show you what was supposed to happen, and those dimensions and everything, you have to work from there, but I'm just going to show you exactly what was going to happen here. Okay, so it's a quadrilateral WXYZ. And remember, I told you when doing construction, make sure that the angles are on the base. Try by all means to make sure a sketch, on your sketch, the angles are on the base. So this is WXYZ and WXYZ. 120. So let us just have our sketch, guys. Okay, so I'm just going to put my, it's a quadrilateral. I don't know the type of quadrilateral, but I'm just going to sketch, guys. Just a quadrilateral. But I have put 120. 120 is something like this, guys. This 120 something a bigger angle like that. So that's my quadrilateral, and this is WXY, which is maybe on the base. So you can put W here, X here, and Y here. So that means this or Z, so that we can have WXY being 120 degrees. So this is just a sketch, 120 degrees. All right, we move on here. What we have, WX is 5,3. From W to X here is 5,3. So we can put here 5,3 centimeters. XY is 5 centimeters. From X to Y here is 5 centimeters. YZ here is 9,1 centimeters. And also WZ is 8,5. So this is 8,5 centimeters. So this is a sketch that you are having. All right. So from this sketch now, let us now construct the actual diagram. So here, that's what we are going to have. Let us just try to shift a little bit here so that we can have the actual diagram. So from this sketch, now you have your actual diagram. Okay, so let's put our actual diagram here. I think it can help us. Okay, so we need our instruments. Okay, so let's just put in our instruments here. All right, let's check our instruments. What do we need? A ruler and a compass. Okay, so for the meantime, these are enough. Okay, so as usual, guys, your construction has to just start from a line, just like this one. It has to start from a line. Make sure that you actually start from a line. Just indicate a line of your choice, and we can even try to push it this way so that it can help us. Maybe something of this nature. All right, so from this line, that's where I'm going to construct the angle of what? Of 120 degrees after that, but I can even measure whatever that I'm going to have. It's fine. I don't know what was best for you, but you can just mark an arc of radius. Remember, 120, guys, it means you have to construct 60 degrees outside of the diagram. Here, you have to construct 60 degrees. So how do you construct 60? Remember, you just need to mark an arc of your choice here, and this is actually too big. I'm just going to reduce. Okay, I've taken the other side too much. Okay, it's fine. Let me shift a little bit like this. Okay, so this is where I'm going to construct my 60 degrees, which means I'm going to construct my 60 degrees on the right, so that 120 is going to remain inside of the diagram. Okay, so remember your 60 degrees, you just need a semi circle of your choice that you're going to work with. From this line, something of this nature, an arc Then we have to construct back to this arc here where this and the line meets. We have to mark back to this arc. Okay, so as you can see, okay, I have taken this, okay, like this. Yeah, I think it's fine. So this is what you're going to do. Then we have to join. All right, we have to join. Okay, so let us put it here and see what you're going to have at the end. So I'm just going to shift this one. Okay, let me just reduce, guys, this. Okay, let me reduce my ruler so that it becomes a little bit smaller. Okay, so I just need 60 degrees, something of this nature here. All right, so join. This one is a continuous line, guys. You have to make sure it's a continuous line because we just don't need this 6 outside, but we need the remaining angle, which is this one of 120 degrees. Okay, so that's it. Now you measure your measurements. Make sure that you've got 5,3 from your ruler you measure, but in this case, I can even take it direct because as you can see, it gives me the direct dimensions here. So I just need 5,3, which is something like this. But you have to measure on your ruler with that dimension that you have, you mark it here. Okay, so you just have to mark to say, okay, this is where I'm having the point W from this part here. This is where our W is located. So this is your W here. Did I take the marker? Okay, let me just indicate the marker that I need to use here. So this is our W here, and this is our X. And this distance in between is 5,3. So this is our 5,3 centimeters in square feet. All right, then all these dimensions, we just need to measure them because we do not have any angle, but this one, Y here, is direct because it's on this 120 degrees. It lies on this line. So you can just measure direct 5 centimeters like this. This is 5 centimeters. Okay, so I just have to step here. With my 5 centimeters, I need to mark it along this line. So make sure you measure on your ruler, then you mark the 5 centimeters that you have. Okay, so this is your 5 centimeters, which is at Y here. Okay, so this is 5 centimeters, all right? Then from these two now, this Z here is not direct, but we know that from W here, we are going to measure 8, this is what we just know. From W, we are going to measure 8,5 centimeters. Okay, so 8,5 from your ruler, 8,5, that would be like this. So you have to measure from your ruler, 8,5 from your ruler. You just mark a point because you do not know exactly where it is going to be located at. So you just mark an arc of your choice like this one. We do not know the exact position. So you just mark 8,5 from W. From Y here, you measure 9,1. 9,1. They are going to meet at one point. That's your Z. Okay. So let's measure our 9,1 here. This is 9,1. So I have to step at this point at Y because I need a line from Y to Z. So that's why I have to step on where Y is located. Okay. So if I mark back to this arc like this, with this 9,1, these two are going to meet at a point like this one. That's where our Z is located. So from this point, it means we can be able to join that Z to Y and also to W. Yes, now our diagram will be complete. So that was the case here, guys. As you can see, we can be able to join these two. All right, just a little bit here. All right, so let's join. And for joining this, continuous lines, but let's just that be a little bit from that point. Do not draw, construct like this, okay? So this is 9,1 centimeters. We can even write 9,1 centimeters. Now, since we now have our Z here, and we can do the same, join Z here to W, just a little bit here. Okay, so I think I just need to shift here a little bit on this side. All right, let's just solve, guys. On your diagram, there are on your diagram, definitely they will just join direct, but here because of this diagram, guys, you know, these constructions when you are using these instruments and so forth. But it's something like this. I just hope it's there. Just hope it's there. Okay, let me see by joining. Yes, it's there. Okay, something of this nature. Okay, so that was going to be your diagram. Just a little bit from that point like this, and you're done. You're done. You're done. So that is what we actually needed, and this will be 8,5 centimeters. So on your diagram, it's going to be a little bit bigger than mine, because here, remember, just look at my ruler, how it is located. Or next time, I'll just say, I was supposed to use these ones here on the other hand, which is this 1, 2, 3. Yeah, because, yeah, I think it can actually be this one, but they'll be too bigger on our diagram. So I'll just have to see what is best. But here, I just, as you can see, it's just a smaller part, a smaller presentation, but on your diagram is going to be bigger than what you see on this one. Okay, but that was it. That was how you simply need it. And on the other part, we are now asked to, okay, the locus of points which are equidistant from W and Y. So this is locus. Remember, from your locus, a locus of point equidistant from 2 points, W, and you bisect the line AW. Here, this is going to be line WY, where these two, they are on a line. So you construct, you bisect that line WY. Okay, so that's it. So let's bisect our line WY. Remember how you bisect a line, guys. This is W to Y here. So you can, from this point W, you just have to mark from point W. You open more than half of the line because it's like you're going to have a line if like this. Let me just show you what was going to happen here. We're supposed to have actually a line like this from the point W here to point Y like that. Okay, but you're not joining, you are not joining anything, just construct your points. Okay, by just stepping at this point, you can clearly see, okay, this is more than half, or like this one, you can see this point is actually more than half. So there's no need for me to indicate all those guys. Just see this is more than half. So what do I need? I just have to mark an arc. Remember what you do, you mark an arc inside the shape where you want to bisect, somewhere here. So it's going to be maybe somewhere here inside the shape, definitely. And the other one will be somewhere this side here. Okay, somewhere here. So you can just have our arc like this. We move on to Y here. We do the same at point Y here. We mark back. So we're going to mark back here on this arc, mark here. And we shift back here to this side. Okay, without changing any length, you do not change any length. You shift like this, you mark. So as you can see, they are joining at a certain point. They're actually meeting at a certain point. So what do I need? I have to join these 2 points. All right, yeah, somewhere here I can actually have my points joined. So just join, it's a continuous line. Just join this line. I don't know where it is going to end up. Just join a little bit from okay, I just wanted to extend the ruler, not here. Just want to, okay, let me extend this side. All right, so just join just a little bit bigger line from what, because somehow you might need to use this line. So do not join direct to the point, just exceed a little bit like this. You can just exceed. So what have we done? We have bisected the line WY here. Okay, so that was the part. Let us go back to the question. X and Z. So we need the same again, equidistant from X and Z. So we're going to bisect line XZ. Okay, so we need line XZ. Okay, so this is it. X and Z. This is X here. This is Z. So just like what we did in the previous question, you were supposed to join, but there's no need for you to join, guys. You're supposed to join here from X here to, maybe you can do that, but use broken line, okay, from X to Z. But actually, there's no need. You can clearly see from your X here. If you step here, you need to point at X. Okay, you can see, okay, this is actually more than half. You can even see that this is more than half. So there's no need for you to do that. Okay. Then with this more than half, you construct an arc on this side. You go to this side, you do the same, you construct an arc on the other end. You go now to this point at Z. Remember, it's X to Z at XZ here. We refer back here, we mark our arc back, and we have to mark our arc also on that side. So as you can see, they are joining. Yeah, they are joining at this point and at this point. So where these 2 arcs are joining, what am I going to do? I have to join them now using ruler. All right, so using our rulers, something like this, just maybe a little bit like this one. Okay, so we can actually join these 2 lines. So like I said, make sure that is a little bit bigger, not direct, but a little bit bigger like this. Okay, so that's it. We have bisected the line from what? the line xz. So that is what we had from this part here. All right, so let's see the other question that we are given. All right, mark and label clearly the point O inside the quadrilateral, which is equidistant from x, w, x, y, z, and so forth. So this is the point of intersection of these loci that we had, these two loci that we had here, the item 1 and the item 2. Where do they meet? That is where you're going to mark point O inside the quadrilateral. So as you can see, definitely actually inside this point here. So you just mark and write it also. To mark, you just indicate, okay, then you write O aside. That is to mark it, right? So that is it. And draw a circle here with radius OX. So what are you simply doing? We are just going to the point O, direct to the point O like this. This is your O here, and radius X. So it means from O to X like this. This is my radius from O to X like this. It means that's our radius here. From O to X here. That's our radius. So construct a circle. From that point, just draw a circle. It's going to be like this. Okay, so if you do that, you're going to generate a circle like that. So this is the circle that you are having. As you can see, this circle is passing through W, it is passing through Y, it is also passing through Z. Okay, so that was it in this case. Just to do that, you are done. And let's see the other part of the question in this case. So, okay, I think that was direct. Draw the radius, okay? Measure and write down. Measure, you measure using your ruler, then you write down. Okay, not on that point, but as an item. So this is C, whatever item that you're going to have, C item 2. You measure using your ruler, then you write down your answer. That is what they mean. Okay, so here the radius you measure, but as I can see here, this is the radius that I used here to measure this. So on this one is going to be 4,9, as you can see here. It's 4,9 on this display. It's 4,9 centimeters. So that is what you're going to measure. If you measure, you're going to obtain something like 4,9 centimeters. I don't know exactly from your diagram. This is not direct, okay? So you just have to work from there. That is very, very important. Okay, so that was it, guys, on this platform, on this part. So I'm just going to remove this, but so that you can actually see what we had. So your diagram was going to just look just a little bit like this one. So guys, make sure that you construct properly. Okay, so let's see the other part of the question, which is actually the last part. State the special name given to the quadrilateral W, X, Y, Z. Okay, they are saying this is a quadrilateral. It has got a special name. Yes, from W here to X to Y to Z. As you can see, all the four angles, they are on the circumference of a circle. So from our circle geometry, we understand that this is not just a normal condition where all these four vertices are on the circumference of a circle like this. It's not just normal. It's a special type of a quadrilateral. And what quadrilateral is that one? It's called a cyclic quadrilateral. So this is a cyclic quadrilateral. So that was a cyclic quadrilateral. I don't know if you are to measure from this point to this point, if you are going to obtain the same measurements, if you measure from X to Y, X to W, W to Z, if these are the same, then it was going to give us a kite, but no, because these sides, they are not the same. Here it's 5,3, here it's 5, here it's 9,1, here it's 8,5. So it's not going to give us a kite. It's a special shape, which is a quadrilateral with all its four vertices on the circumference of a circle. So that was actually the consideration of this question. Guys, you have to be very, 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 very careful when you are answering these questions. Make sure to revise. This is the right time for you to revise, guys. We do not have time for this and that at this time of the moment. This is the time for you to be revising as many question papers as you can. So that was the question actually. So I just, okay, just think everything was clear here. All right, so let's see the other part of the question is now question 7, which is on section B. All right, so let's see what we are having on this part. Yeah, let's. All right, so this is just, guys, in mensuration, if you are dealing with mensuration, you must know your formulas. That is the best thing. Know your formulas on mensuration. And actually, these were solid shapes. So here we are given calculate the volume of a copper ball. So this is a copper ball. Remember, a ball is actually a sphere that you'll be having. It's not a circle, but that one is a sphere with radius 3 centimeters. So you need your formulas, but lucky enough, they gave you the volume of a sphere in this question, but it's not like always you're supposed to expect this in your exam. No, it's not like that. Okay, so this is our item A, where we are given that the volume of a sphere is given by 4/3 pi r cubed. So this one, that's our volume. Okay, let me just try to wait until it saves a little bit. So that we can have our question. I hope it's now there. So we're given 4/3 pi r cubed. So this is the volume, which is 4/3 times pi. Always you use the pi that you're given. In this case, your pi was given as a 22/7 times r cubed, which is the radius now. So this is a copper ball with a radius of 3 centimeters. So just insert your 3 centimeters, but with exponent of 3. Okay, so that was it. This one, you just use your calculator, guys. Everything on your calculator, you're going to obtain 792/7. So this is a cubic centimeters volume. Or as a decimal, you're going to obtain 113,14 and so forth and so forth, 14. 38, so this was 2828 or something like that. Okay, so remember our dimensions are like the units that you're going to have to 3 significant figures, guys. So to 3SF, you're going to obtain 113. But in this case, since we are going to use this, it's best for us to just leave to 3 decimal places. Okay, but to 3SF, it was going to be 113, but it is best for just maybe 3 decimal places. We are going to use this later on. So I'm just going to put this to 3 decimal places, and I have to indicate to 3 dp. I have to indicate here. But to 3SF, it will be like this. So, but for later use, we are just going to use that one. Okay, so the copper ball in A, this is B now. So they are now referring to that copper ball that we had in A. It was melted and recast into cylindrical rods, each of diameter 0.3 centimeters and length 15 centimeters. Remember, a cylinder, that's our cylinder, something of this nature. So we are given the diameter, which means we have got the radius of the cylinder, which is half of this diameter. Remember, radius is diameter over 2, so it's 0.3/2, which is going to give us something like 0.15. Okay, that's 0.15 centimeters. So that's our radius here. 0.15 centimeters, and this is the height, which is the length. So you're given the length of 15 centimeters. So each is going to have these properties, okay, if we recast it. So now they are asked to calculate the volume of each rod, okay? So what is the volume of each rod that we are going to have? And if you are to check here, we do not have that volume of a cylinder, we just have of a sphere. So that means you need to know this. And we say that the volume is simply base area times height. So this is base area, whereby volume of the cylinder is base area, and on the base here we've got a circle, that is pi r squared times the height. Okay, so that is pi r squared h. So pi, you use that pi that you're given, 22/7 times radius squared. We said our radius is 0.15 squared times the height, which is 15. So we're going to have the volume of each rod that we are having. And if you are to simplify this, you're going to obtain something like 297/280. 297/280. This is volume measured in cubic centimeters. So that's what we get in this case. And we can actually put this as a decimal, which is going to give us 1,060714, something like that. Okay, so to 3SF is going to be 1,06, because this 6 can be, this 0 cannot change because it's less than 5. So this is cubic centimeters. Okay, so that was our item 1, sorry, B item 1. Then now we are asked to find the number of copper rods that can be made from the copper ball. So we've got copper rod, and a rod is a sphere. This cylinder, sorry, this is your cylinder to represent the rod, it's a cylinder. And we need how many of these from what? From the copper ball, which had a volume, and this was the volume of a copper ball here. So the best way for us to have this one is to use this fraction, because a fraction is an exact answer, this one. So I'm going to use this volume of a sphere. Okay, so for us to know, since we have got volume of one rod, this is the volume of one rod. So how many are we going to have? We just have to divide the volume of a sphere, divide to the volume of what? Of a cylinder, the number of cylinder rod that we have. And the volume of a sphere in this case is the one that we got here, which is 792 over 7. So this one is going to be 792 over 7. Whatever that I get here, I have to divide to the volume of a cylinder. And the best answer to use is this fraction here, which is the exact value, which is 297 over 280. Okay, so this you are simply dividing like this on your calculator. This is how you're going to represent it. You simply have this 792 over 7 like this, divide by 297 over 280. Okay, like this. Okay, so that's what we simply needed from this part. Okay, so I'm just going to perform the division here. So we said 792 over 7, whatever that you're going to get here, we divide to 297 over 280. And we are going to obtain the answer. It was 297 or what was 297 over 280. Okay, that is 297. So we're going to obtain 320 over 3. So we're going to obtain 320 over 3, which as a decimal is going to give us 106 comma something like that, 106 comma 6, 6, 6, and 7, so comma something like that. Okay, so how many copper balls are we going to have? Like the copper rods that are we going to have? The number here, like we are saying, the number we have completed 106 of them, and this can actually approximate to 107 because this can round here, so it can approximate to 107 balls. Okay, so that was the case. In this one, it's an approximation. So if you use the decimal, it's fine, but here we're supposed to work out with this. Okay, so that was the question on item 2. How many balls are we going to have? All right, then from there, we are now given that each copper rod is bent to form a circular bangle. Calculate the radius of the bangle. Okay, so what is being bent is this copper rod, this one. This is your copper rod, this one, which is a cylinder. So we then made copper, we then made bangles from this part. Okay, so this is the idea that you're supposed to actually know, is that the area that you're going to have at the end will be the same, like, let me put it this way. This is a bangle. A bangle is now a circle. So you're going to recast this into a circle like this. This is a bangle, this one. So what is going to happen is that the radius of this bangle, let us get back here. I want us to see what we're given. We are given here that the length, you're going to see that this length here of 15 centimeters is going to be the radius of your bangle. Okay, so this length of 15 centimeters here is going to be the radius of your bangle in this case. Okay, so that means this bangle that we have is going to have a radius of 15 centimeters. That is what we are setting. So that height is going to be turned to give us a radius, okay? And what we know is that we want to find the radius now that is going to affect like our bangle, like the actual radius, because here is the radius that we have taken from the height, okay? So this is the case. For us to find that radius, we are simply saying the area, because we are dealing with a circle. So the length of a circle actually, okay? So this is not like there, let me put it this way, because if we say the height is the radius, I'm going to confuse a lot of you. So let's remove this statement for meantime. Okay, we are saying we need this radius, okay? So what are you going to do? We are going to say, to find this radius, the exact radius, because we are saying the exact radius of the circle is supposed to be taken from 2 pi r, which is the length, okay? So what is going to happen is that this length actually of a circle, so it's the circumference of a circle. So that is your circumference. There's a video that I made where I was explaining how you fold this I was actually using a diagram to show you that. So this one is going to give you the radius of which is the height, which is the length. So the circumference is your length from what? the cylinder that we had, that length of the cylinder is your circumference, this one. So our length was 15. So I want you to correct that. This is 15. The 15 is for this circumference of the circle. So you're given the circumference of a circle, which is 15 now from that length that we have. So we're going to equate this to 15 centimeters. So what does it mean? As we are supposed to calculate, I want you to see what are we supposed to calculate. We are supposed to calculate here the radius of the bangle. Okay, so this is what we actually need to calculate the radius of the bangle. So we are going to take this advantage now to say, since the circumference of the circle is going to be equal to the height, so therefore, okay, let me take this to drag. Okay, I want to drag to this piece here. Okay, this side. So we are going to take this radius circumference and equate to the length. So that means we can divide by 2 pi. Remember your pi is 22 over 7, so you can substitute 2 times 22 over 7 times radius is equal to 15. So since we want to calculate radius here, we can multiply this 2 times 22, that's what, 44. Yes, 44 over 7r, which is equal to 15. So how can I find this? I can divide by this here. I can just divide, or I can cross multiply. After cross multiplying, I can actually divide, or depending with what is best for you. Okay, so let's just do what you are used to do, cross multiply. Okay, so we cross multiply, it's 44r, which is equal to 15 times 7, that's 105. So you're going to obtain 105 divided by 44 here, divided by 44 here. So this can cancel. So the radius now is going to be equal to 105 divided by 44, which is something like 2,3, something like that, guys. 2,38, and so on and so on, 6,3, something like that. So the three significant figures are going to be 1, 2, 3. And this 6 is going to change this into 9, so it's going to be 2,39 centimeters. Okay, so that was your radius in this case. So you just have to play around your formulas properly in this case. Yeah, you have to play around with your formulas. In this case, that was actually the idea. So this is C item 1. No, just C. This is just C, part C. Okay, so let's see the other part now of the question that we are given, which is the D part. If each bangle is coated with silver paint, so take note, guys, we are now coating that bangle with what? A silver paint. And this paint, it costs 5 cents per square meter. Calculate the total cost for coating all the bangles that are being formed, giving your answer correct to the nearest centimeter, to the nearest cent. Okay, so we are given that each bangle that we are going to create. So calculate the total cost of coating all the bangles that are being formed. So in this case, what are we going to have? We need to know, like, how many bangles are we going to obtain from this? Okay, like how many bangles are we going to have? Remember the area that we had here, the total, we can actually obtain the total surface area from this one. But let us first find the area. Let us first find our area. So this is actually D, part of D here. So we can have the area of the bangle, which is the area of the bangle here. Let's reduce like this. Okay. So since we've got the radius, now we can find the area, because we know that area is equivalent. It's a circular angle, this one. So area is equal to pi r squared. Okay, so this is your area here. So you've got your area, which is equal to pi r squared. So pi 22 over 7 times radius squared. That is the radius, which is 2,39. So you multiply to 2,39. Okay. Then times the cost now. Okay, so let's just find our area first. Okay, so this is going to give us something like, this is squared here, radius squared. So if we have to simplify this, we are going to obtain something like 17,952, something like that, which is square centimeters. That's 17,592. Round off, I'm just going to use these digits like as they are, because here, so that we can obtain something that is exact, but it was supposed to give us 9 here, which is 10, and 18. Yeah, we're supposed to work with 18 square centimeters. Okay. So if we are to multiply here, because remember the cost is actually 5 cents, so you can say each square centimeter, maybe we can just put it somewhere here. All right, so you can just say, since each square centimeter is equivalent to 5 cents, what about this 17 comma, or now which is 18, what about 18 square centimeters? What is the cost? So it's 18 over 1 times 5, which is going to give us 18 times 5, which is 90 cents. So this one is going to give us 90 cents. Okay, so that was actually the consideration that you're going to have in this case. So make sure that you actually understand the concept that you're given on this particular questions. It is actually going to help us in attempting any question that follows. So that was your question 7. As we can see, guys, actually you just need to understand what you are given. That information is very, very important so that it doesn't like affect you when you're answering these questions. Okay. Then on number 8, we are given the graph that is answer the whole of this question on a sheet of graph paper. All right, so we just need our graph paper in this case. All right, so let's just see what we are having here. Okay, I just need to put a graph paper here, guys. Let me just insert a graph paper so that at least it's going to be easier for us to work from. All right, so this is our graph paper. This is question 1 to question 8. All right, so let's just hope it's not going to take us much time. Okay, so this is our graph here. All right, so I'm just going back so that we can work. Okay, this one is actually affected us. All right, this is what I'm going to do, guys. For the meantime, is it possible for me to shift these two? Is it possible? Yeah, possible. Okay, so that's it. We have our question. So the question was answered, the whole question on a sheet of graph paper, and we are given the following is an incomplete table of values of this quadratic graph, quadratic function, since the highest exponent here is 2 on this x squared here. That's our highest exponent there, which is 2. So make sure that you understand the graph that you are given. In this case, we are given a 2. Sorry, guys, this thing, it saves after some time, so that's why it is behaving like this. Okay, anyways, find the value of P and the value of Q. So how can I find the value of P? I just have to substitute minus 2 into the equation that I'm given, which is the quadratic equation, this one. So that is when x is negative 2. So P is going to be, in place of x, substitute minus 2, so it's 12 plus 2 times x. Your x here is negative 2, so it's negative 2 x minus x squared, which is open bracket negative 2 squared. So from your calculator, everything, guys, paper 2, make sure you use your calculator, is going to be 4. So P is going to be 4 in this case. Q, you do the same, is 3. So which means your Q is going to be 12 plus 2 into 3 minus 3 squared, like this. Okay, so from your calculator, this is going to give us 9. So this is a 9 here. And using a scale of 2 centimeters to represent 1 unit on the x-axis, 2 centimeters, 2 units on the y-axis, draw the graph now. So you just need to mark our points from this part here. Okay, that is when x is negative 3, y is negative 3. So take note the scale, guys. Okay, so that's our scale here, 2 centimeters, then 2 units on both axes. So that's what we have got here. 2 centimeters on the y, then 2 units, and on the x-axis to then 1 unit. So this is 2 centimeters. These are 10 boxes. So that's 1, 2, 3, and so forth. And this is your y-axis, something like that. Okay, so that was your graph here. So let us mark our points so that it can actually help us. So the first point is negative 3, negative 3. Okay, so that is when x is negative 3 here, y is negative 3. So when we have negative 3 on y, it's in between negative 2 and negative 4 here. So it's negative 2 and negative 3 somewhere here. Okay, we mark our point. We move on to the other point that we are given. It's negative 2 and 4. So when x is negative 2, y is 4. So that's negative 2, 4 here. So let's try to reduce here. So x is negative 2 and y is 4. So negative 2 and y is 4 somewhere here. All right, so that's no. Let's mark exactly -2. Direct here, x minus 2, y 4. Y says 4, so it's at this point here. All right, so that's -2, 4. And we move back here. Okay, so we've got -1 and 9. So when x is -1, y is 9. So that's somewhere here on top here. All right, so that's -1 at this point, and y will be 9. So 9 is in between 8 and 10. So this is 9 here. So -1 direct on top. This is -9. Since each box is representing 2, 2, so which means half of this box is 9. So this is -1, 9. The other point, let's see what we give. So make sure, guys, you mark these points correctly. So this is 0, 12 here. When x is 0, y is 12. All right, so let's see what are we going to have on this part. That's 0 here and 12, which means we have to reduce a little bit back here. So that is the condition here. When x is 0 here, y is 12 at the end there. All right, so we mark that point 0, 12. And we move on to the other point. Make sure that you mark all the points and they are very, very visible. This is 113, 212. Okay, so we've got 113 and 212. So let's just hope it's not going to waste my time. 1 and 13. Guys, we actually need 13 and we do not have that 13 here. So it was supposed to be maybe somewhere here, guys. As you can see, it's not accurate. I didn't see that this point is going to be out of our scale. So anyways, let's put back our diagram to the exact thing here. Okay, so it was supposed to be somewhere there. Okay, so guys, I hope you saw that one. Okay, then we move on to the 3. It was 3 versus, it was 2 versus 12. So this is 2 versus 12 here. 2 versus 12. And the other one, so I just hope that that point, guys, you saw it, that it was, yeah, something else. Okay, so this is 3, 9. Okay, let's see where our 3, 9 was. If I'm to redraw this graph, it's going to take me a lot of time. So this is 3 versus 9. Remember, 9 we said is in between 8 and 10. So this was 9, 3 here. This is 8, 9 somewhere here in between half of this. Okay, so this is 3, 9. And the other one was 4, 4, and 5 minus 3. So this is 4, 4. Just make sure that you mark all the points. X is 4, Y is 4. Where these two meet is at this point. That's 4, 4, and 5 minus 3. So remember we said the last one is 5 minus 3. So when X is 5 here, Y is minus 3. This is minus 2. This is minus 2, minus 3 here. In between minus 2 and minus 4. So this is somewhere here. Okay, so that's the point. So after having these points, we are supposed now to join them properly, guys. So on the joining part, I'm just going to reduce this. Let me see if I'm going to win for joining. Since that point, guys, as you saw that that point now is no longer accurate, so it is going to affect us. Make sure that you draw a smooth curve by joining the points that you're given to 12 here. It must go to that 13, then it comes back to this 12 here. All right, so here now I can't like shift like what I used to use on that actual graph where I had to shift my graph so that it can be smooth. But guys, that's how you're supposed to have it. You just have to join. This is no longer smooth. Let me just remove this part here. The top part here, maybe I can just try to reshift this so that it can be smoother than what it looks like. All right, so that's it here, something of this. All right, guys, you just have to draw a smoother graph. That is what it means, because here, as you can see, it's giving us, there is a point 2 that is missing. That is why this graph is looking. Okay, the 2 here, this is our 2. You see, this is -2, -1, and this is 1. And this point is not exactly where it is supposed to. That is why our graph is like this. Okay, the 1 here is here. The 112 is here. I hope someone saw that and was like, what is happening here? Okay, so this is 112 here. 112 here. This point, this is our 112 here. All right. Then 2, it was actually 2 versus, it was 113. 113, oh, 113 is this one that we have, not 12. So it's 113. Okay, this is 113 here. Also, the 113 is there, is here. And the 2 was the one that was not direct. The 212, this one is here, 212. All right, now it can actually make sense. That's why our shape was like, what is this part? Okay, so you have to join this part. Then to this part here, all right, join this part like this. Yeah, it must be smooth. So remember this point I'm just going, it's not accurate. That's why you see our graph is just like, so you on your graph, guys, this is supposed to be exact, but like I said, it's going to take me a lot of time to redo this and so forth. But I just hope you saw what it's supposed to be like. So you just have to draw a smooth curve, your graph. So that was your graph, guys, like this. And with this graph, what am I going to do? I just have to write the equation as it was. So remember our equation was y is equal to, that was 12 plus 2x minus x squared. Okay, so this is the equation that we had from that graph. So make sure that everything is actually neat and not glossy, okay? So here we are now given on C, item 1, use your graph to find the roots of the equation. So these are the roots of the equation of the graph at 12 plus 2x minus x squared is equal to 0, which means where this graph passes through the x-axis, that is where y is equal to 0 here. That is what they mean. So where y is equal to 0, this graph is going to pass the x-axis at these 2 points here and at this point. These are the solutions of the graph. Okay, so that is our C item 1. So this is C item 1. So x, you count the boxes here. So according to mine, actually the one that I did, it was negative 2,7, something like that. Okay, so it's negative 2,7 for x is equal to, here is going to be 4,5. Okay, but there's now 4,6. So I don't know according to your graph, but according to this one, it's 4,6. Yeah, they're supposed to be within those values. Okay, so those were the values that we had from this part. That is the solutions. Okay, let's see the other question that we are given. So make sure, guys, you understand the information that you are actually given. It actually helps you to answer. And also your diagram, it must be smooth. The graph must be actually be smooth, okay? So that you do not have those problems now finding, okay. Then the second part on C is to find the gradient of this graph at x is equal to 2. So remember, guys, what I told you, to find the gradient, what are you supposed to do? You draw a tangent where x is equal to 2, okay? So where x is equal to 2 here, so x is equal to 2 direct to the graph, it meets this point here. This is the point where it is going to meet. So you draw a tangent at that point, okay? So we need a ruler here so that we can have our tangent at that point. Remember, a tangent simply touches the circumference of the circle. It doesn't enter into the diagram, it just touches the circumference of the circle. Okay, so let me just try and reduce this ruler so that we can draw a tangent. And that tangent must be at least 3 centimeters long, at least, which means more than or equal to 3 centimeters. Okay, so that's our tangent here. Where x is equal to 2 at this point, that's where we draw our tangent here. A tangent, it just touches the circumference of a circle like this. Okay, so from this tangent, what are we going to do? We have to pick 2 points from this tangent where this tangent meets with the curve. So the first point was we want to find the gradient, and you know that the gradient on a straight line is the same. So the first point to pick on this tangent is the point where the tangents meets the graph at this point here, which is at x is equal to 2. Remember, this is x is equal to 2, and at that point, y is equal to 12. So that is the first point that you're going to take, okay? Since you want to calculate gradient, we are going to use points. So we say the first point is at x is equal to 2, and at that point, y is 12. And you pick another point on this line that you have drawn, which is your tangent, okay? So any point, as long it is on this line of the tangent, you can pick that point, okay? So I'm just going back to the 3 here. When x is 3, direct here at 3. So if you are to see, the 3 is going to correspond with 10. So this is 3 versus 10 according to my graph here. X is 3 and y is 10. This is the point. Y is 10 here. X was down there, was 3. So this is the other point that I'm going to take. So you just take 2 points. In this case, this is what I want to take. You can take any point. Here it can be, let's reduce our graph so that we can see properly what I'm doing here. Here we said x is 3. As you can see, x direct is 3, y is 10. So you can take any points, any point of your choice, okay? So I've got these 2 points, 3, 10. So with these 2 points, now I can find my gradient. Remember, how do you find your gradient? Simply the increase in y over the increase in what? In x. So that means you can even name these points. This is your x1, this is your y1, this is your x2, this is your y2. So that means this is our item 2. See item 2. All right. So that means gradient is equivalent to the change in y over the change in x. That's y2 minus y1 over x2 minus x1. Or you can use y1 minus y2 over x1 minus x2. Still is fine. So y2, yes, 10. So it's 10 minus y1, which is 12, over x2, which is 3. So it's 3 minus x1, which is 2. So that's what I'm going to do here. So 10 minus 12, that is negative 2, over 3 minus 2, which is 1. So I'm going to obtain negative 2. Okay. So actually, guys, your actual gradient, the actual gradient of this question, because here I'm using the exact presentation of a graph and an electronic device that I'm using. So definitely the answer that I'm getting here is the actual answer that you're supposed to have. This one, this is your actual answer, minus 2. So what does it, how are you going to see your answer? Your answer is going to lie in between this answer with plus or minus 0.3. Make sure that your answer is in within this range. So it can be in within this. You just add 0.3 or subtract 0.3 from this minus 2 and see if your answer is in within that range. If not within this range, it means that answer is wrong. So redo your diagram. Make sure that your diagram is smooth, and your tangent, it just touches the circumference of a circle. So you just have to redraw if it is like that, but you must get something like negative 2 or in within that range. Okay, so that was the gradient here. And the other question was, if you are to cross-check, let's see the other part of the question. We want to find the equation. This time is the equation of whose roots are minus 1 and 3. And this equation is supposed to be written in the form. So take note about the format here. So I want us to focus on the format first. When we are saying that 12 plus 12x plus 2x minus x squared, this part here, what does it represent? This is your y. Remember, we're saying y is equal to. So in place of 12 plus 2x minus x squared, I'm going to put this as y. So you need the graph of y is equal to x is equal to k, where k is an integer, which is a number, a whole number. So which means the equation that we need is of a straight line of y is equal to k, because this here represents y. So we need the solutions at -1 and at 3. So this is what you're going to do from your graph. Okay, you have to trace back from your -1. You have to trace back here. This is your -1. Okay, this is our -1 here. Our -1. So direct -1 is giving us, if we are to take this straight to the graph using your ruler. So make sure that you use your ruler straight to the graph. Okay, we move straight to the graph here. We are going to correspond at this point here where y is 9 at this point. At 3, we move on direct to the graph because this is the solution. So what was the value of y at that point where we got these two solutions? So this one also corresponds with 9 here because this is 8, 9 here, and 10. So that is the line of y is equal to 9. So if you are to join this, you are going to see that it's a straight line that you are going to actually formulate from this part here. So it's a straight line that we are formulating. Okay, so let's, okay, there are 2 now. Okay, so I'm just going to remove 1. Okay, so if you are to join these 2 points here, you're going to see that you have formulated a straight line which passes through y is equal to 9. Remember, that's how you take solutions. If a line meets a graph like this, you say at the point of intersection, you drop your answer. So this time, you are not dropping your answers. You are starting from the answers to the graph. So this is the graph of y is equal to 9. The line that we are drawing is of y is equal to 9. And we said our equation is supposed to be in the form of y is equal to k, where k is a constant, which is an integer, and our integer is 9. So therefore, the equation is going to be y is equal to what? Y is equal to 9. But we say this y now is no longer written as y. They've written this y as 12 plus 2x minus. So that's what we're going to do. So our equation is going to be 12 plus 2x minus x squared is equal to 9. You now write in the format that you are given. So this is the answer that we're supposed to write, because this whole part here, it represents y. So instead of writing y is equal to 9, you are just writing an equivalent to that y. That is what a tricky part was. That was just a tricky part about this question. Actually, it was nothing to consider or nothing much there. Okay, so that was it, guys. Simply like that. Let's see the other part of the question. We are now given, this is a salary P of a saleswoman who sells cars of the same type is partly constant, and her commission partly varies as N. Okay, so we've got two things here. The salary, which is represented by P. Okay, so let's see how it is going. And we are asked to write this in terms of what? Constants H and K. Okay, so let's take our equation here. Let's put this aside here. Okay, no. Okay, I want this aside, this side. Okay, so we say this is our question 9 here. So the salary, which is P, this is your salary. So P is equal to, okay, partly constant. Yeah, partly constant. Remember, I told you partial variation is just a constant. Okay, and that is a class. So it's and. Your commission partly varies as N, the number of cars. So your commission is a constant that they're talking about. Partly constant as them, so which means we're going to have a constant with the number of cars. So this is the salary, and these are the number of cars. Okay, so this is our salary here. These are the number of cars, these are the number of cars, and this K is your commission, this one, that is your commission. So to calculate K is to calculate commission, that is what it simply means. Okay, so the first question on item A was to express P in terms of N, constants H and K, so this is it, guys, P in terms of constant H and K, so this is your A. B, find the value of H and the value of K. Okay, so which means we have to substitute the information that we are given to solve the simultaneous equation, because here we are formulating simultaneous equation from the information that should be given. All right, so let's save a little bit. So from this information here, you are going to formulate a simultaneous equation. So maybe you can just drag a little bit here. Okay, so let's just formulate our equation. I'm going to zoom after. If she sells 7 cars, which is what are we given? We are given N here. Remember, number of cars is N. Okay, yes, salary is 675. Salary is P. Okay, so P, we are given P here. So this is P. Our P is the salary, which is 675. When the number of cars being sold is 7, so it's going to be H plus K7, which is 7K. K7 is just same as 7K, okay? If she sells 10 cars, we are given N. Her salary, which is P, is what? 900. So we are given P 900. The salary is equal to H plus the number of cars times K. So it's going to be 10K. So that's it. So you can calculate the value of H and K by solving these equations. Okay, so as you can see, H and H are the same here. So you can eliminate by subtracting the second equation from the first one. So we can just solve our simultaneous equations here. We can just subtract so that we can eliminate this H here. So that's what we get. 675 minus 900, that's negative 225. Negative 225 is equal to H minus H, that's a 0. 7K minus 10K, that's negative 3K. So to find K, you can divide by negative 3 here. So our K is going to be positive 225 divided by 3, that's 75. Okay, so this is the value of K. So now to find the value of H, this is what I'm going to do. Substitute into any of these two equations. Here in place of K, so I'm just going to take advantage of the first one. 675 here is equal to H plus 7K. So it's 7 times this K that we have got, which is 75. So that would be, you can multiply these two, then whatever that you get, you transpose. So instead of doing that, I'm just going to transpose as it is. It's a plus here. So if I transpose to the other side, it's going to be a negative. So it's negative 7 times 75, which is equal to h. So that's our h here from our calculator. Our h is going to be 150. Okay. So that was it, guys. Just to calculate the value of h and the value of k. That was the question. And now write down the equation connecting p and n. Okay. Take note here before we had to express p in terms of n and constants h and k. Now we just need p and n. So which means what is going to happen? We have to substitute our values of h and k into the equation so that we can have our p. Okay, our p in terms of n. So this is C item 1. So we have got the values of h and k that we got here, this one, and our equation was this one. Okay, so that's what you're going to have. So this is now C item 1. So p is equivalent to h. Remember our equation was p is equal to h plus kn. So h, we said our h here is 150. So we're going to substitute h, which is 150, plus our k, which is 75, times n. This is kn. So k is 75. So it's going to be 75 times n. So it will give us 75n like this. Okay, so this is the equation which connects p and n. So as you can see on this equation, we just have p and n, which is the salary and the number of cars. So that is the equation. Okay, so let's see the item 2 that we are given. All right, so on the item 2, what are we given here? We are now given the sales women's salary, which is P. Remember, salary is represented by P. So calculate P when she has not sold any car, which means there's nothing that was sold, which means our N is equal to 0, nothing. So we want to know if she sells anything. If she sells nothing, like nothing has been sold, what is the salary? So your N is equal to 0 here. So if N is equal to 0, what is the value of P? So we're substituting on this equation now that we are now having. So our P is going to be equivalent to 150 plus 75 times 0 here, which is going to be 150 plus 0, that's $150. Okay, so that was the salary for the sales women. If she never sold anything for that month, she was going to get something for just being at work. All right, so that was it, guys. Let's see the other part. Calculate the sales women's salary when she sells 9 cars in 1 month. So what are we given? We are given the number of cars, which is 9. What are we calculating? The salary. Salary is written by what? By P. So that is our D. So we're simply substituting any this time must be equal to 9. Okay. So that means this is our D. So P, remember our P is equivalent to 150 plus 75N. So we start from there, which is 150 plus 75 times N. We said now we've got 9 cars which were being sold. So what is the salary? So if you multiply this, you're going to have 150 plus 75 times 9, which is 675. So if we add these two, we are going to obtain $825. Okay, so this was the salary for the saleswoman for this month if she had to sell 9 cars. Okay, so guys, answer your questions properly, understand the information that. So make sure that you understand your questions very, very much. That one is very, very important. Okay, now given that your commission is 2.5% of the price of a car, calculate the price of each car. Year commission. What is year commission? Actually, we want to see here, guys, what is happening here. The commission is actually a fixed price. It's like it's a commission is like a percentage that you get for a price of a car. Okay, like each car that you're going to sell. And if you are to check back here, I want you to understand here. Let us come back here together. Remember, we are told that here it's a commission, which partly varies as n. So commission is multiplied to the number of cars which is being what? Which is being sold. So if we are to check here, this is the commission here. This is the commission here. K, we said K represents our commission. And our K, we got that K as what? As 75. So what it means here, our commission is 75, our value of K, that is your commission, okay? So they are saying, if your commission, which is your K in this case, remember this is your commission K, we got 75, now is we can write it as man, which is 75 plus. Then what was the price? Because a commission is 2.5% of what? Of the price of the car. And we know that the commission for each car is 75 plus. So what are we going to say? We are simply saying 2.5% of each car, that is times the price of each car, which we do not know the price of the car. We've got a commission of 75 plus. So what is the X here, which is the price of each car? So this X is price of each car. So that is what we need to know. Okay, so how can we calculate this X? Remember, this is a percentage, guys. And how do you remove, the percentage first? 2.5 is same as 2.5. So this is same as 2.5%. So how do I remove percent? I divide by 100. So it's going to be 2.5 over 100. So take note. So this is going to be 2.5 over 100x, which is equal to 75. Okay. So to calculate the amount now, okay, so this is our E here. Okay, so now to calculate the cost of the car, what are you going to do from this? We are saying, if truly the amount, the percentage here times X gives us 0.5, so we're going to just solve our equation. So how are you going to solve this equation? Okay, I need to put this back. Okay, so we have to solve, that is, you can cross multiply. I don't know what was best for you. You can cross multiply. 2.5x is equal to that 1 times 2.5. Since you have cross multiply, 1 times this remains the same. So it's 100 times 75, which is 7,500, if I'm not mistaken. Here, divide by 2.5 both sides, divide by 2.5 both sides. So we can have the value of X. So if we divide properly, we are going to obtain $3,000. Okay, so each car is costing $3,000 here. That's the price of each car. For her to get a commission of 75 plus, it means the car was actually sold at what? At $3,000. Okay, so that was the consideration actually of the person. So like I said, guys, it's very, very best that you understand each person, read the information to understand the information that you're given. Each and every information, you have to read that information, and it's going to be very, very helpful if you do so. So that was it, guys, on question number 8. Okay, so we have to see the other person, which is part of the graph, and also the other one is a quadratic. So solve the quadratic. In fact, solve the equation. You're not given it's a quadratic, but you have to know this is a quadratic equation. The highest power is 2 here, so we are solving correct to 2 decimal places in this case. So so your quadratic formula, yeah, is to make sure that you just apply your quadratic formula here. So remember, guys, your quadratic formula is x is equivalent to negative b plus or minus the square root of b squared minus 4ac everything over 2a. All right, so what we need is to make sure that we locate what is our a, our b, and our c. So our a, the coefficient of x squared, our a here is 3. So that is our a here, which is 3. So our a is 3. And if you have to cross-check, our b is -5, the coefficient of x here. That is -5. So that's our b here, which is -5. And our c here, which is -15. Okay, so this is your c, which is equivalent to -15. So you can substitute into this formula. X is equivalent to minus b. So take note, it's minus, and our b is a -5, so it's -5 plus or minus the square root of b squared. Make sure you've got your negative b squared like this, minus 4a, which is 3 times c, which is -15. Just put this in brackets since you're multiplying, and everything all over 2a, so it's 2 times a, which is 3, like this. Okay, so that's it, guys. You can actually put in your calculator, simplify. So what I want you to do is to simplify properly. Negative and negative, that's a plus or minus the square root of. So this is the part that I want you to simplify under the square root, the whole of this part here. Simplify that one separately, it is going to give you 205. So this is going to give us 205 here. All right, so this is 205. Everything over 2 times 3, which is 6. So at this stage, yes, you can separate now. That's plus and minus. So it's going to be 5 plus the square root of 205 over 6. Or another x is going to be 5 minus square root of 205 over 6. So depending with your calculator, if you are using those DAL calculators, then it's going to be, yeah, you have to adjust your calculation. This is what you're supposed to do. On your DAL, you're going to do like this. Okay, let me just put it here. You're going to open bracket for this part here on the top here. You put it in a bracket like this, open bracket like this, exactly like what I'm doing. You open bracket 5 plus square root of 205 like this. You close the bracket, then you divide by 6. You're going to obtain an answer, which is the same here. But if you are using an advanced calculator, then there's no need for you to do that. Just put in your fraction as direct the display as you can see here. This is your display on your calculator as it was supposed to be. So if you do that, your x is going to be 3,219, something like that, 3,2196, if I'm not mistaken there. Or the other x is going to be negative 1,55 actually, 297, something like that. So now the degree of accuracy we are given here, correct to 2 decimal places. You use the one that you are given to 2 decimal places, okay? So to 2 decimal places, that means we have to round off this. So our x is going to be 2 decimal places, that digits after the comma, 1, 2. So this 9 is going to round off this 1 into 2, that's 3,22. Or x is equal to 2 decimal places, that's 1, 2. As you can see, this 2 can no longer round off, so this is going to remain as 5. So it's negative 1,55. Okay, so these were the two possible values of x that we're going to obtain. Okay, so let's see the other part of the question, which was actually on the cumulative frequency. Actually here, the masses of the following is a cumulative frequency table. So take note, already they did a table for us, that is the cumulative frequency table for a survey carried out on the masses of 80 secondary school pupils. As you can see, the total here is 80. So you are not doing anything. You're not going to construct any table. This is the table that you're going to use direct as it is. Okay. So here we are given on the item 1 using a scale of 2 centimeters to 25 kg on the horizontal. This is your horizontal. 2 centimeters to 10 on the vertical. So this is your vertical, this is your horizontal. So draw the cumulative frequency. Remember, the cumulative is drawn using the upper classes, and here you use the cumulative frequency, of which you are already given the upper classes. These are the upper classes, and these are the cumulative frequency. So that's why I said you are not going to change anything. You just have to use the graph as it is. Okay, so I have to just insert that graph here. So I'm just going to see if I'm going to win, guys. Let's just hope I'm going to win here. Okay, I want to put a graph on this one. Okay, not on this one, not on this one. Here, yes, that's where I want to put a graph. So I just hope it's going to allow us guys to do so. Okay, so this is it. Let's see where's our graph here. It's question 10b. All right, so we have our graph here. I think it's clear. Okay, so this is our graph. Make sure that it's according to scale, the cumulative frequency, like I was saying, 2 centimeters to represent 5 units here. So here I'm going to start at 45, like what we are given, 45, but here starting at 0. So it's 45, here 0, 10, 45, 50, maintaining 5 units throughout. That way is going to actually help us. So this is cumulative frequency here. Okay, so I think everything is perfectly there, and 80 there up to the last one. Okay, so let's mark the first point. We just have to mark the points here, guys. Okay, so I think this page is an extra page. Let's just remove this one. Okay, yes, we do not want this. All right, so we need the other one, which is this one. Okay, so this is what we need, this page here. Okay, so the first point is 45 here versus 2. So you have to mark 45 versus 2. So take note also according to your scale, how you are going to read according to your scale is very, very important there. All right, so 45 versus 2 here, according to the y-axis, remember it's 1, 1, 1, 1, 1, 1, because these are 10 boxes here. So it's 1, 2, 3, up to 10. So 45 versus 2, it means we are going to, okay, we are going to have it somewhere here when we have got 45. That's 2, you have count 1, 2 boxes, that's 45 versus 2. So it's going to start at this point. This one is not going to start from the ground this time, so it's going to start at this point. Okay, then we move on to the other one. That is 50 versus 10. Okay, so that one is 50, and the cumulative frequency is 10, because that one is cumulative frequency. The other one is what? The upper class, this one 50 versus 10. So it's 50 versus 10. This one is direct here. All right, so that's how you simply mark your points. You move on to the scale. Make sure that you mark all the points, 55 versus 21. So let's locate our 21. It's very, very important for us to locate that 21 from your graph. Okay, so okay, let me put the graph. Okay, so this is 55 versus 21. So where are we going to have the point 55 here? This is 20. So he said each box is 21. So 55 versus 21, just count one box. So this is 55, 21. We just have to mark all those points to the last one. So the other one was 60 versus 41, 60 versus 41. So I'm just going to reduce like this so that we can see where our 41 is there. Guys, I'm just going to mark you so those points, okay? So it was 60 versus 41. So this is 40, 41, one box. 65, it was versus 60, 65 versus 60. Okay, so this is 65 versus 60. So 65 versus 60. Okay, this is your 60 here. All right, we move on to the other one. It was 70 versus 72. Let me cross check now. I've forgotten this one. So you just have to cross check, guys. Okay, it was 70 versus 72. Okay, 70 versus 72. All right, so let's mark our point 70 versus 72. So this is our 70 here, and 72, guys, I have to reduce this. I don't know if it is going to be clear. 70 here and 72. So it's 70 here, then 72. This is 70. Okay, this is your 70 here, then 70 here, 72. 1, 2 boxes. Just have to calculate 2 boxes like that. Okay, then the last one was actually there's 75. We see we have 75. Okay, we've got 75 versus 78 and 80 versus 80. Okay, so that's 75 versus 78. 75 now is in between. Take note, 75 is in between here. Okay, this is your 75 here according to scale here. That's your 75 according to this box. Remember, the whole of this box is 75. So it's 75 versus 78. 78, which is 75 is here. Then 78, this is your 70. This is 75, 76, 77, 78. This is 78. Then we have got 80. Versus 80, so your 80 is the last one, this one 80 versus 80. Okay, so this is 80 here versus 80 on this side. So this is our 75, 80 here versus 80. All right, so that's it, 80 versus 80 here. All right, so that is what our graph was going to look like. Then all you need is to join this to make a smooth stretched S. So this one is going to formulate a smooth straight S like this one. That's something of this nature. All right, guys, we just have to draw a smooth graph here. Okay, it's only because here, guys, I won't be able like to reshift, but you have advantage here. You'll be writing, you'll be doing this on a paper, so you can also be able to shift your graph so that it can fit actually the process that you want, but it was going to be something of this nature. Make sure that you just have it in a smoother way. Okay, so let it be in a smoother way. Yeah, something of that nature. I just think that it's fine, but guys, all these gross things, they're not needed. Let it be smooth. Okay, so that's your cumulative frequency. That's how you have your cumulative frequency. You mark your points properly. Then when you join, it must give you a straight S like that. Okay. So that was the part on this one. And we now have item 2. Use your graph. Take note, what I'm using here is your graph. The graph that you have is the one that you're going to obtain your answers from. So which means your answers may not be exact, but they are going to fall into the same range of answers. So the item 1 was to find the median mass of the peoples. Okay, so how do you find the median? Median, this is half of the distribution, so it's going to be half of the distribution. This is your total, which is 80. So it's half of 80, which is 40. So we are saying at the 40th position, so this is like a position where you're going to obtain your answer from. So on the 40th position, that's where you're going to have your median, on the 40th position. So we mark where our 40 is here. So this is our 40. So we have to draw direct. You can actually use our ruler here. Okay, let's just see our ruler. So at 40 here, what am I going to do? I'm going to, okay, let me do this. Okay, I'm going to shift a little bit here. So at 40, this is what I'm going to do. At this point, you draw straight line at 40 to the graph. Okay, so that line is going to meet this graph at a certain point. So you draw, you can even use a broken line like this. Okay, so this is it. At this point, you have to now draw to the what? To the horizontal. This to the horizontal here. So this is going at 60, somewhere there. Yeah, you just have to mark properly. So according to my graph, it's going to 60 here. As you can see, it's going to be at 60. So like I said, it depends with your graph. So the answer, you take it on the horizontal. So on the horizontal, our answer is 60 in this case. Yeah, just depends with guys what you have. So in this case, this is our median, which is 60. Not the 40. The 40 is the position. Then the answer is 60 now. So this is 60 what? The mass was measured in kgs. Remember, here is your answer in the horizontal. And in the horizontal, as you can see here, I've written mass is measured in kgs as you are given on that table, your mass in kgs. So your answer is 60 kgs, okay? So that's what you're going to have here. Okay, then the number of people whose masses are more than, take note, their mass is more than 72. Okay, so this time we need the number of people. So we're going to start from the horizontal to the graph, like our graph like this, to the horizontal to the graph, horizontal to the graph. But we need more than 72. So where is our 72? That is what we simply need. Straight to your graph. This is 70 here. 7 according to our scale. Remember, this is 5. So each box, what does it represent here? These are 10 boxes. So it means each box is 2. So like each box is 1. 2 boxes like this is 1. So this is 41. Like this is 41, 42, 43, 44, and we have got this is 45 for heads. Sorry guys, this is 45 for heads. So this is 46, 47, 48, 49, 50. So it's 1, 2, 3, 4, 5 like that. So each 2 boxes represents 1. Okay, so as we need 72, so 72 is going to be at this point here. This is our 70 here. So we need 72. So 2 boxes represent 1. So like this, 1, 2 like this. This is your 71. Then we count 1, 2. So this is our 72 here. So this is where our 72 is going to be located at. So, but we need masses which is more than 72. So what am I going to do? I have to join from this 72 to the graph, straight to the graph. It is going to meet with that graph. So we need our ruler back here. Okay, so we need our ruler so that we can be able to join. Okay, so this is what it's going to look like. Direct with your ruler here at 72. All right, that's somewhere here at 72 here. So what am I going to do at this point? I'm going to join this one. I can just use broken lines so that I can be able to join properly. So I can just use broken lines here to indicate that this corresponds to what? To 72. Okay, so guys, I'm just missing this point a little bit. Okay, so that's 72 here. Okay, just a broken line. At this point, it meets the graph at this point. So where that point meets the graph here, we have to join now from that. Now to the vertical point here, which is going to correspond on the graph, and that's somewhere here. All right, where these two meet. So if I'm to join here to this point, that's where my answer is going to be located from. Okay, I wonder, or it needs me to just save. Okay, it's saving. This issue of saving, what is I'm writing, guys? You see? No, just wait, because if it stops, guys, you're going to lose everything here. Okay, just hope like this. Let me put back my marker. So guys, let's just be patient enough, because this software, it saves after some time just to save. Okay, but something like this. Okay, so this is what we actually needed. So this is at more than what? At more than, say, this is at 72. And what is the corresponding value here? Remember, on the y-axis, each box represents 1. So this is like 71, 72. Let me put this one. So it's like 71 here, 72, 73, 74, 75, 76. So this is at 76. But remember, we need more than, so it means from 76 up to the total, and our total is at what? Is at 80. This is your total cumulative frequency at 80. So we're going to subtract these two so that we can have our answer. So our answer is going to be 80 minus 76, which is 4. So that means we had, or you're just going to draw here from this one, we're just going to draw from this 80 here. This is what we're going to have from this 80 here. We're going to mark, but here I'm just going to use it, but you're going to use your ruler, guys, at 70, it's at 80 here, because this is your last point. Okay, as you can see, it corresponds here with what? With 80, but that one there's no need for you to do, because you can clearly see that it corresponds with 80. So the difference between these two, these are the ones which are more than what? More than 72, because more than 72 is from 72 to 80. So which means we have to subtract both at 80, they are 80, and this one they are 76. So the difference between these two, okay, that is the number of students. So in this case, we're going to obtain 5. So it depends, guys. If it was at 75, then it's 80 minus 75. So remember, this graph of mine is not as smooth as it's supposed to be, but that is what we are supposed to have in this case. So that's how you attempt these typical questions, guys. All you need is to be very, very accurate with the information that you'll be given, the information that you're given. So I think, yeah, that's it. I think we have got everything in this case. So please do revise as much questions as you can, guys. We do not have time, so we just have to revise as much as we can. Okay. Number 11, we are given, this was a vector. So we're given a vector here. These are like points that we are given, like that normal vector that we have in our paper 1. So given in the diagram, this is a quadrilateral. Okay, then we are given OP from O to P here, it's -1, -2. OX, this one is 5, 0 like this. Okay, so that was the question. And the first question is to find vector XP. So we just need a root here from X to P. So what is the root that you're going to take from X to P? Okay, so X here to P, this is the root that is going to be XO plus OP. So it's going to be XO plus OP like this. Okay, so from X to O, as you can see, take note on your diagram what is happening. We are opposing the direction of what? Of the arrow. The arrow is going this direction and we are going this direction. That is our XO. Like this here. Okay, sorry. I think I'm placing my mouse on the, okay. So like this one, we are opposing, going this direction. So it is going to be like this way. Okay, so this is the direction. So definitely it's going to carry a negative. So it's negative of OX, because OX was going this direction. So it's going to oppose, which is -50 here, plus OP. OP still maintains the direction. So it's going to maintain as it is, which is -1, -2. So that's it. We can expand our brackets by negative. Negative times 5, that's -5. Negative times 0 here, that's a 0. Plus -1, -2. So remember your vector, guys, from your paper 1, how you simplify these vectors. So we are going to add here plus and minus, that's a minus. So it's -5, -1, which is -6. So this one is going to give us -6. 0 plus -2, that's -2. Okay, so this is your vector XP. So we are done. Then the B part, on B item 1, we are given a consideration that vector XR is equal to HXP. Now express this vector xr in terms of what? In terms of h. We are already given, vector xp is there, this one. So it's just a continuation. So it means item 1 here, our xr is going to be h times xp. This is your xp here, which is -6, -2. So you can multiply h times -6, that's -6h. H times -2, that's -2h. So this is your xp. Item 2, show that OR is equal to this one. Okay, so as you can see here, your OR is in terms of what? It's in terms of h. As you can see, it's in terms of h. So we need a root that is going to include of xr, because xr is so far the one that is containing h. So your root, the root that you're going to take to find this vector OR, this one, it must contain h, which means it must contain xr. Okay, so how are we going to find our OR? So our OR in this case, this is item 2. Our OR is going to be, we need the root now, but this root must include xr. Okay, so this is our OR here. And xr has to be included. So which root are we going to take? As you can see, this is the root that we're going to take from O to R here. So we're going to take OX plus XR. As you can see, XR is involved. Okay, so OR here is OX plus XR. Okay, so that is it. So we said we are going to have OX plus XR in this case, okay? Whereby OX is given as what? As 50. So this is 50 here plus that XR, this is your XR here in terms of H, which is -6H, -2H. So you can combine 5 plus minus, that's a minus, so it's 5 minus 6H. As you can see, these are unlike terms, so you can't simplify. 0 plus minus 2 is same as 0 minus 2h. So you can't simplify this. You just have to remain with what? -2h. 0 minus 3 is -3. 0 minus 4 is -4. So 0 minus 2h is -2h also. So this is your vector OR. Okay. Then another consideration, we are given that OZ is equal to 3OP. So let's see what we are given. From O to Z is 3OP. Okay, that's our OZ here, which is 3OP. Okay, that is from O to Z like this. This is the whole of OZ here, from O to Z. They are saying is 3OP. Remember, this is your OP, which is this one. So now multiply by 3. So it's 3 times -1, which is -6. So I'm going to remove this. So we are given now from O to Z, the whole of it. So 3 times -1 is -3. 3 times -2 is -6. So this is your OZ. And what else are we given? We are also given ZY is 2OX. Okay, from Z to Y. This is our Z here to Y. And we are told that is 3 is 2OX, which means you multiply OX times 2. And this is your OX, which is 50. So you multiply that one by 2. In this case, so it's 2 times 5, which is 10. 2 times 0 here, which is 0. So it's going to give us 10, 0 like this. So we have given vector ZY and vector OZ. And the question, what is the question now asking us to do? The question is asking us to find OY. Okay, so how can we find vector OY from this one? We need the root that we are going to take from O to Y. Okay, and that root is going to be, as you can see, we now have everything from O to Y. We are going to use OZ plus ZY. Okay, so that's going to be OZ plus ZY. So guys, play around with your diagram. Okay, so as you can see, we start with Z, we start with O, we start with O, we end with Y, we end with Y here. So OZ is the one that we said here. Remember your OZ, the whole of this, which is -3, -6. So that's -3, -6 like this. Plus ZY, we also found this ZY here. This is our ZY, which you said is 10, 0 here. So this one is 10, 0. So you just have to add 10, 0 like this. So you can add -3 plus 10, that's 7, -6 plus 0 here, that's -6. So that's our vector OY here. So that was just direct like that, guys. As you can see, it was a matter of just substituting your values, isn't it? Yeah, just substituting your values, then you can simplify. So that is your OY here, which means we are done on this part. Then we've got the other part, which is now given that if OR is equal to K, OI, express OR in terms of K. Okay, OR is equal to K, OI. So let's just put it here. This is D item 1. Okay, so this is the item 1. We are given that OR. I'm just going to write it here. Okay, let me put the marker, the item 1. So we are told that OR in this case is equal to K or Y. Okay, so this is what you're given. Now express OR, that is the first question here. Express OR in terms of K. So we have to multiply, because already we have got our OY. Remember, this is your OY here, so we're just going to multiply K. All right, let me just wait a little bit for it to save. So that we'll be able, okay, I think now it's fine. So you can substitute the information that we have so far, which is K times OY here, which is 7, -6. So multiplied by 7 is going to be 7K. Multiplied by K here is going to be -6K. Okay, so this is vector OR. Okay, so this is your new vector OR here. And the other part now on item 2, use the results in B item 2. Let's see, B item 2, this is B item 2 where we showed this OR here. This was your B item 2 where you calculated OR. And D item 1, D item 1 is where we calculated again OR in terms of K. Now use this to find the value of H and the value of K. So what are you simply doing? You are simply equating B item 1 and D item 2. On this one, we are simply equating this vector OR and this OR, they are equal. Okay, so this is our D item 2. So from our D item 2, we are saying vector OR from the first one is supposed to be equal to the same vector OR. That is what we know. And this is a column vector, so we're going to equate them in column like that. Okay, so the first vector OR is this one that we got here on B item 2, which is 5 minus 6h minus 2h. So we're going to equate that one. So it's 5. This one as it is 5 minus 6h minus 2h. So this is a column vector. You equate to the column of OR this one, which we have, which is a column, which is 7k minus 6. So it's going to be 7k minus 6k like this. So these two are equal. So how can I find the value of k? As you can see, these are normal vectors, guys, where we know that corresponding elements are equal. So I can formulate equation 5 minus 6h is equal to 7k. These two also, they are equal. Minus 2h is equal to -6k. So you have to solve the equations. Just like normal equations, I don't know what is best for you to solve this, but you can reduce your equations. These are equations, okay? So look what I'm going to do. I'm going to take this one, but you can solve any way or anyhow. So this is what I'm going to do. I'm going to take this one and play around this one because there's something important here. Minus 2h is equal to minus 6k. So I can divide by -2 by -2 here. That means h is equivalent to 3k. Okay, so I formulated another equation. This was my equation 1. This was my equation 2. Now I formulated third equation. So I'm going to use substitution since h is equal to 3k. Okay, since our h here is equal to 3k, I'm going to substitute this h, which is equal to 3k, into the first equation, this one, so that I'll be able to solve for this case. So I'm going to have 5 minus 6 times h. Our h is 3k, so it's going to be 3k is equal to 7k. So 5 minus 6 times 3, that's minus 18k, is equal to 7k. So I now have an equation which has got only k here, so I can solve for k. How am I going to solve for k? I can transpose the -18 to the other side of the equation. Is going to be a plus. So that means I'm going to have 5 is equal to 7k plus 18k. So 5 is equal to 7 plus 18, which is 25k. So this is 25k divided by 25, divided by 25 here. So our k is going to give us 5 into 5, 1, 5 into 25, that's 5. So it's going to be 1 over 5. So with this value of k, to find h, was already I have a subject of here, I've made h to be the subject. So I'm going to start here where we said h is equivalent to 3k, and we have to substitute now the k that we got. So our h is going to be 3 times this k, which is 1 over 5. So this is same as 3 over 1. So it's 3 times 1, which is 3 over 1 times 5, which is 5. So this is the value of h that you're going to have, 3 over 5, your k, which is 1 over 5. So that was the case in this consideration. So play around with these values properly, guys, okay? And then the last part is to find the numerical value of the ratio XR over RP. So this is XR over RP. How do you find this ratio? You have to cross-check where you are given this XR and RP. And from your diagram here, XR and RP here, this way we have got this line XR here. Let's just erase some of the things here. XR here. All right, so you have to consider this line here, which contains everything from X to R to P. Is there any of the statements which used these letters XR, RP, or XP, anything that has got these letters from the information that we were given before? Let's cross-check from our information that we were given before. From the information that we were given before here, I want you to see what happened here. We say we're given here XR, XP. This is what we have, XR, XP. We are given that XR here is equal to HXP. This is what we are given here from this B. Okay, we are given that XR is equal to HXP, and we got that H here. We calculated our H, remember what we got here on our H. Our H here was 3 over 5, okay? Here our H was 3 over 5. So I'm going to substitute that H now, which is 3 over 5 here on this statement, because this statement is referring to say this is HXP, and our H we said is 3 over 5. So this means XR is equal to 3 over 5. I want to change this one. So it means is 3 over 5 of XP. So this is your XP here. All right. Okay, so this is your XP here, like this. So what does it mean? It means the whole of XP, remember this 5 here represents XP, and this XR represents 3. So from X to R, we've got 3 parts here. That is what it means. From X here to R, we've got 3 parts. But the whole of XP, this line XP, it has got 5 parts. The whole of this line X to P, it has got 5. So out of 5, we have removed 3, these 2. So how many parts are going to remain? So it's 5 minus 3, which is 2. So it means from R to P, we've got 2 parts. So we can attempt this one because the question was for us to calculate this ratio of XR like this over RP. So XR is there from X to R is 3 over from R to P. R to P is 2. So it's going to be 3 over 2 like that. So this is your ratio now, the one that you're given, which is the numerical value of the ratio. You're writing the numerical value, not just in terms of the letters that you're given. No, before we are given this in terms of letters, now we need the exact value, which is the numerical answer or the numerical value from that information. So please make sure that you play around this information very well. Okay, so that's what we actually had on this vector. As you can see, guys, it's actually a play around type of a question. You have to play around with the information that you're given, but that's what we had to obtain 12 marks. That's all actually what we did. Okay, so let's see the other part, which is the last question of the paper, which is transformation, question 12. Okay, I just need a graph here. All right, so let's just put in our graph here. All right, so let's just put our graph for this one. All right, so let's get back to our question. Okay, so we need to remove this one. Yes, remove this. Okay, so that was the question, guys. Remember, you'll be given a scale to work with, and from that scale, make sure that you understand the scale that you're given. So here we're given triangle W as vertices at 1 minus 1, and this use a scale of 2 centimeters, 2 units on both axes, on the X and Y. So as you can see, this is the scale that I indicated here. So we can actually play around this scale to suit everything, your X-axis and your Y-axis, everything is there. All right, so that was it, guys. Let us mark this part and see what you're going to have. So we need WX angle, triangle W. So you need to just mark these coordinates 1 minus 1, 7. So as you can see, it's just W. It's not like A, B, C. So you just mark these the way that they are given. Okay, so the first one is 1, 1. 1 minus 1 and 7 minus 1 and so on. So you just need to mark as it is, guys. Okay, so let's mark this is 1 minus 1. When x is 1 here, this is 1, 2, 3, 4, 5, 6, 7, and so forth. Okay, so I put 1 minus 1, this is minus 1, minus 2, minus 2, minus 3, and so forth. So we need 1 minus 1, which is this point here. The other one was 7 minus 1, which is this point here. And the other one was 4, 4, 4, 4, which is somewhere here. When x is 4, y is 4 on top there. So these are the points that you're supposed to join. All right, so let's just take our ruler here and see what you're going to have at the end. So let's just hope this graph, guys, is going to finish, because yeah, it's now a lot. And just hope this software is going to understand me for today, because I have actually abused this software today. I did a lot of things. Anyways, let's see, guys. Let's join. Just going to use the black one here. All right, so that's it. We also join these 2 points, or we can just even reduce a little bit. But make sure that all the points are clearly indicated, or clearly drawn. Yeah, clearly indicated. Let me reduce this graph, guys. I think it can help us. Okay, let me just reduce this one, because now it's too big for us to work with. So let me just reduce a little bit here. All right, that's somewhere here. All right, so like I said, guys, everything has to be directly presented here. But because, guys, as you can see, it's now giving me hectics here, I'm just going to join. Okay, so this is here. And the other part on this side, you just have to join also. That's something of this nature. All right, somewhere here. All right, so that was our triangle. This is the triangle that we are going to have. And inside this triangle, that's where you just name triangle W. So you're not given, says W what is just W. So you just mark it to say that's my W here. This is the first triangle. Okay, so the second triangle is given that draw and label, sorry, triangle. So triangle X is the image of triangle W under a reflection in the line of Y is equal to X plus 2. So what we need here, we just need to draw the line here. Y is equal to draw the and label this line. Y is equal to X plus 2. So you can use table of values. Y is equal to X plus 2. You choose to use your table. You just pick 3 points of your choice from the X and Y. You substitute, or you can just use double intercept like I want to do here, because I just know here when X is equal to 0 here, Y is going to be 2, and when Y is equal to 0 this time, when Y is equal to 0 here, what is the value of X? I can simply use that concept. So when Y is equal to 0 here, what is the X? We have to transpose 2 to this side, which is negative 2 is equal to X. So X is negative 2 using double intercept. So I just need to mark these points 0, 2 and minus 2, 0. Okay, so that's 0, 2. These are the 2 points. These 2 points, they are enough for me to draw a line. So you can use table values, it's fine, as long as you're going to obtain the same thing. Okay, so like I said, 0, 2. So this is 0, 2 here. So I'm going to mark this point 0, 2. And other one was negative 2, 0 here, negative 2, 0. So these 2 points, they are enough for us to have or to draw our line. In this case, so I'm just going to draw my line here, which is 45. Now it's going to be something else, 45 here. Okay, so I need to join this. Make sure that also this line is big enough. Okay, so this line must be big enough. Okay, so let's put this way. Okay, I think this now is big enough. Okay, so that's your mirror line. This one, this equation that you are drawing is the mirror line of the triangle, or that you are going to draw later on. Okay, so that's what you're going to have. You just have to mark the points properly, then you can draw the image. And also you have to name the equation of the line. This is y is equal to x plus 2. Okay, that's the equation of the line. So that was it. Remember reflection, guys. How do you draw the image? I told you if the line is it's a slanted line like this, you have to create 90 degrees. Each point moves to the line, then it creates 90 degrees, but it maintains the same distance. So here we're going to move half box. Remember, according to the scale, this is half of a box, so it's half box up, so it's one box here. So we moved one box up, we create 90 degrees, we move one box to this side because our image is supposed to be on this side here. This is where our image is supposed to be on this side. So you move one, then you create 90 degrees to this side, one. So this is one box, two boxes. So it's actually two small boxes at this point. Okay, you're done with this point. You do the same to this point. You move to the mirror line. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. So we mark our point. So you create 90 degrees, then the same distance that you moved going up is the same distance that you move to that side. Okay. The same here, you do the same. You move to the mirror line. That's 1, 2, 3, 4. We move to that point. 1, 2, 3, 4 to this point here. Okay, so this is the point. So these points are the ones that we are going to join now to create our triangle. So that's it, guys. We can actually join our triangle here. All right, so let's join these 2 points together. All right, so that's it. We're going to join these 2 points together. All right, then we join the other points here. All right, so just a little bit here, somewhere there. All right, so we join these 2 again. Okay, we do the same from that angle. Here we join these 2 points. So that's how you simply work out reflection, guys. If it is a reflection, you're given the mirror line, you just have to move. But remember, I told you guys, it depends with the way that you're given. Sometimes, if you are given a vertical line, you don't produce like what we did. You move straight to the mirror line, then straight from the mirror line. But in this case, because of this part, the line, the slanted line like this one, you're not going to do that one direct. Okay, so that was the question. As you can see, guys, we've obtained a lot of marks by just doing this. And the other part of the question, you are now given that draw and label triangle the image of W under an enlargement, scale factor minus, take note, we are given the scale factor is minus half, the center is the origin. So this is enlargement, and remember, you can use matrix because I told you guys from the matrix of enlargement K00K, where K is the scale factor. So the scale factor here is negative half, which as a decimal is negative 0.5. So we are going to just use our matrix method since we know that matrix times object gives us the image. So what are we multiplying? We are multiplying the coordinates of the object, which is this one, W. This is your W here. All right, so this is our C. Item 1. So matrix times object is equal to image. So this matrix can work since the center is what? Since the center is 0, 0, you just have to use it direct. So our matrix now, we said is a half here. In place of K, you put minus half or minus 0.5. So since we want to do calculations, let us put it as minus 0.5, 0, 0, minus 0.5 for calculation sake, but it's minus half here. Times the object. Your object now is triangle W, which has got coordinates at 1, minus 1, 7, minus 1, and 4, 4. So this is it. Remember, matrix times object, you get the image. So it's row by column, this row by this column. So if you multiply, what are you going to have here? Minus 0.5 times 1. This is going to give us negative 0.5. So it's negative 0.5 plus 0 here. Negative 0.5, you know, this column, negative 0.5 times 7. That's negative 3.5 plus 0 times 1, which is a 0 here. Negative 0.5 on this row, on this column is negative 0.5 times 4, which is negative 2. Okay, we are done with this row in this column, or all these columns. We now move to this row, back to this column. So it's 0 and 1. As you can see, it's just a 0 here. So we're going to work out this negative 0.5 and 1. That's our positive 0.5. All right, then we move on to this row here. So it's 0 and 7, that's a 0, so there's no effect. So we just have to multiply negative 0.5 here and negative 1, which is going to give us positive 0.5. 0 and 4, that's a 0 here. So negative 0.5 times 4, which is -2. So that is what we are going to obtain. So this is your image, which is the triangle y now, but you just have to write this as coordinates. Like this is a point, which is -0,5, 0,5, like this is a point. You move on to the other one. This one, -3,5, -3,5, 0,5 is a point. And the last one is -2, -2. So these are the points that you're going to mark on your graph, and you draw your image. That's it, just like that. So let us mark our points. -0,5 now, guys, according to our scale. We have to understand this scale much. What is it represent? Remember, this is like 0, 2, 4. So -0,5 is in because this is like -1 here. Let me just indicate some other things here. All right, that thing now it has to save. No, guys, it must wait because we still need this page. If it doesn't save, guys, it means we'll be under bad luck because I won't be able to read this person, guys. As you can see, it took me a lot to finish up this. Okay, so anyways, remember we said this is -1, -2, -3, and so on, -1. So -0,5 is in between these two boxes. Actually, 2.5 boxes, 1, 2.5. So also here, 2.5, so it's 1, 2.5, 2.5 also. These are 2.5. So it's in between here, in between those boxes, in between, not at that point, in between. Okay, and the other one is -3,5, -3,5 in between again, and the 0,5, so it's 3,5. This is 1, 2 in between, guys. Do not check. It's actually in between there. Okay. So this is what you're going to have somewhere there. And the other one was -2, 2. That one was -2. Was it -2, 2 or -2, -2? Let us cross-check our question again so that we become so space. It's -2, -2. Okay, so this is -2, -2. So this is -2, remember? And this is -2, so it's somewhere here. Okay, so these were the points, guys, as you can see. Then we have to just join these points here. All right, something now I have misplaced my ruler now because of this. Okay, let me just insert another one. All right, so that's it. Here we join these 2 points together. All right, I'm just going to use the black one here to this point. All right, then there are the remaining of the points, guys, as usual, just like what we're doing on the previous points there. So we just have to make sure that you join properly in this case. All right, so this is it, guys. Let's hope at this point, yes, we are able to join. That's like this. And we do the same from that point. We join these 2 points on this other end. So it's gonna be something like this. All right, so let's join these 2 points like this. All right, so like what we have got, that is our y. So as you can see, why is it is enlargement, but this image is smaller because of the scale factor, which is a fraction. Remember, I told you when the scale factor is a fraction, the image is going to be smaller than the object. Okay, the image will be smaller than the object whenever you are given a fraction on your scale factor. Okay, but that was the case. And as you can see, guys, it was just actually direct, and you just have to name your point. What was this triangle's name? It was X. You just drew this triangle. Okay, this was X. Okay, let me put it back. This was X. Okay. Yeah, I think it's clear. Okay, let's see the other part of the question. I hope we are still together, guys. The other part now is write down the matrix which then this transformation already the matrix we wrote it. This is a presentation, but the matrix now is substituting this half now. So the matrix is going to be this one where k is minus half. So remember we said it's k 0, 0, k, so it's like this. So this is the matrix that they need. You do not write the k. K is just a presentation. So this is your matrix, okay? Then D, we are given a triangle Z with the vertices 1, minus 3, and so forth and so forth. Draw and label triangle Z, then describe the transformation. Okay, so let's draw the triangle Z together. We just need to mark the points that we are given. In this case, we had Okay, so let's get our points again, guys. I didn't cross-check those points and I don't know where I was rushing. Okay, 1 minus 3, 1 minus 9. Okay, let's mark these points. 1 minus 3. So it's 1 here, minus 3 here. So x is 1 at this point. Okay, I need this one. Okay, so x is 1 here, y is minus 3. Between minus 2 and what? Minus 3. Minus 2 and minus 4. Then minus 9, this is minus 7 here, minus 8, minus 9. So it's 1 straight to minus 9 here. This is the point. And the other one was 6 minus 6, 6 here and minus 6 here. All right, so these are the points. Okay, so you need a ruler back so that we can join this point. So this is a triangle Z. All right, so that was our Z here. All right, so let us join this and see what you're going to have at the end. So you just have to join just as usual. So that's it here. All right, I need this part a little bit up here. All right, so just like what we did, guys, we just need to join this one, but because here I just need to shift so that I'll be able to join properly these 2 points. All right, so somewhere there, guys, I'm just joining so that we know actually what it's supposed to be like. But this is what you're going to have at the end. And make sure that the points, they are actually drawn. This must intersect like this one. Okay, then you do the same. You join your points, guys, as usual. Then from there, you can actually have your diagram completed like this. So that was your triangle there, which is your Z. So this is your Z here. And it was not only about drawing this triangle, but also describing the single transformation, which maps, or take note, it maps W onto Z. So which means Z is the image and W is the object. Okay, so Z is your image and W is the object. And the object is the one that you started with, actually, that one that we had here. So it's our object here, this is your object. So as you can see, this point, these are actually congruent figures. So the answers that we already know the answers that we're going to expect to have. We are going to expect to have from your congruence, translation, reflection, and rotation. These are the 3 answers. But which one? Let us join and see what is going to happen here. We just need to see the magic after that. After joining, everything is going to work. So which part are we joining? You can see that this point here corresponds with this point. So these are the 2 points. Just join using dotted lines. In this case, yeah, it can actually help us. Just use dotted lines in this case. Okay, so from this point to this point, let's just see if it is going to be clear. Like this one. Okay, so just join using broken lines, but here I need another mark and I don't know which one is best that I can use here. I don't know. Okay, but just join using a broken line like this one. Okay, so these 2 points. Okay, then after that, you can see that this point here is the one that corresponds to this point here. So these are the points that you're going to join. This point and this point here, they correspond to each other. You join corresponding points. Remember, the concept is to join the points which correspond to each other. So let's shift over so that we can be able to rotate it like this. All right, so that is it, guys. We just need to join. Okay, so if we are to join this, we can actually see that no, it's actually not what I need here. Or should I just erase? I don't know. Okay, like this. Okay, let me just use that one now. The marker is taken. Okay, like this, guys. Okay, like this, like this, like this, like this to Z here. So this is what you're going, as you can see, guys, by just looking at this, you can see these 2 points, they intersect, and it's actually rotation, because translation, remember, parallel lines, you create parallel lines of equal length. Reflection, parallel lines of an equal length, but rotation lines, they cross like this one. So because this was the last point, as you can see, yes, this one, they're not joining it, they're not crossing each other, but these 2, they intersected at each other like that. By just having this, that is a rotation. It's the only transformation under isometries that allows, which gives us such consideration. So you can write it is a rotation. Okay, so this one, it is a rotation. Remember what you need on rotation, you need the center of rotation. And I told you, to find the center of rotation, you bisect these lines, especially these two lines which are intersecting these ones. Okay, so we are going to bisect those two lines so that we can have our center. We are now back to construction, guys. All right, so how do you bisect a line? Remember your bisection, you open more than half of the line and so on and so on and so on. So I'm going to start with this line here. From this point, I'm going to start with this one here, this one, which corresponds to this one. So this is the line that I'm bisecting here. So remember, you open more than half of the line. So at this point here, just open more than half of the line. So as you can see, it's actually more than half of the line. Then we mark an arc. So I'm just going to mark an arc on this side here, arc on this side, and another one on this side. Okay, we move on to the other point, which is here on this point where it meets. Okay, so back to this point, yes, it's going to allow us. Yes, they are joining actually. So guys, it's just because of this, it saves after some time. So let's just hope it's going to allow us to finish, guys, because as we can see, this is the last part. But that's what you're going to do. You just have to join those points. Okay, let's hope it's going to allow us to finish. We are almost there. Please just allow us to finish. All right, so this is the case. Join this point, back to this point, join this point. Okay, so where these meet, I have to join now using my ruler. Okay, so we need our ruler here. All right, so that's something of this nature here. Where the point of intersection is the one that you join. Okay, so you join the point of intersection, you're going to see a magic after that one. If you were to see, so I'm just going to use a continuous line because I'm having a different marker here. I'm just going to use a continuous line, but you can use broken line. I want you to see what is happening. What we have done, we have bisected this line here. We move on to the other line, which is intersecting. Remember, these are the two lines which are intersecting. You bisect this one now. This one is the one that you are bisecting. Let me indicate the one that you are bisecting now. Remember, we bisected this one in red. Now we are bisecting this one here and this one that I've indicated with this black, like this one. This is the one that we are going to bisect. Okay, so for the meantime, we have the instrument. We need our compass so that we'll be able to bisect here. All right, so just like what we did from the previous part, you open more than half of the line from this point here. This is our point. To this line here. So as you can see, this is more than half of the line. Let me just change the marker so that it doesn't disturb our points. Let me choose this one. Okay, so more than half of the line, you just mark an arc. I'm going to mark an arc here. And also on the other side of the equation now, because of this arrangement that I'm having, I hope it is not going to affect us, but we're supposed to mark an arc on this side here. Okay, so just like that. And we have to move to this point and do the same again from this point. Let's see if they're going to intersect. Yes, here they intersect. Okay, what about these ones? They do not intersect, so which means this arc was supposed to be somewhere inside. Okay, so I just have to change to this point. There's no need for you to worry about. You just need to change this to this point again. Okay, so you just have to come back to this point again and reconstruct. Okay, so reconstruct back like this. So they are going to meet actually. So like this one that we had. All right, then we get back to this one again. Let's get back to this one. Okay, so let's put it this way. We want to go back to this point here, to this point. Okay, so I have to continue with this until it meets. So as you can see, they're going to meet here. It's not exactly where it was, yeah, somewhere here. Now, if you are to put this, it was at this point. I just want to maintain what it was. Okay, like this, they're going to meet at this point. Okay, so these arcs, they met at this point, and at this point, I have to join them. Okay, so where's our ruler? Let's get back our ruler here. All right, so that's our ruler. All right, so you have to join the point of intersection. So I'm going to use a yellow one, just like what we did in our previous part. I'm just going to use yellow so that we can actually see the exact thing that is happening here. I hope, guys, we are together here. So join. these two, like this one. Okay, so these points, they intersected all these two bisectors. So we bisected two lines, and these bisectors, they met at a certain point. Where these bisectors meet, that is where your center is, and they meet at this point here, which is at, if you have to cross-check, that is at -2. Remember, your scale, guys, they meet at this point here. It was 0, -2, -4. So that is your center. Where these 2 points meet, that is your center of rotation. So our center is 0, -2. So that is our center, 0, -2, like this. Then we need the angle of rotation. So the angle of rotation, what you do, you just have to join these points here, any corresponding points, okay, to the center. Here is your center, so you can just join any points to the center, like this one. I can just join this point to the center, and also this point to the center. Okay, you join them to the center so that you'll be able to measure. But because of our time, guys, I'm just going to use dotted lines with freehand here. But you're going to understand, you join to the center like this. No, let us use, now I'm doing something else. All right, so let's just put back our ruler, but I hope you understand what I'm trying to do here. All right, so this is it, guys. We're going to join to the center. Okay. Any point, so you join corresponding points actually. So I'm going to work with this point here. This point here to the center, this is our center here at this point, okay? So you join that one to the center. So you can just use broken line. Let's see which one. You can use the red one. Okay, so you just join to the center like this using your broken line to the center to this point, okay? You do the same, the corresponding, remember this point here and this point, they correspond. So you join this one to the center also, okay? So you join 2 points which corresponds, not all of them, just 2 points, they're enough, okay? So like this to the center. Let's join our point here to the center. All right, so to the center, if we are to join like this, this is to your center here. There's an angle that is being created with this red line, this one, red, this one. There's an angle created, this one. This is the angle that you're supposed to measure now. But you are measuring from W to Z. So as you can see, this direction from W going to Z this way, this is clockwise. But what is the exact angle now? So what you need is your protractor. All right, so you take your protractor there, you place this protractor here. This line here, this black line, this line here has to cover the line, this one, the red one from W, which goes to what? To Z. So it must cover that one, okay? So I'm just going to rotate. Now I do not know this, okay, this one I rotate like this, okay. So this black line has to cover this like here at this point at the center. Then this line must cover that line which goes to the broken line, that one. So as you can see, this line is passing through actually at this point at okay, let me shift it like this one. All right, so this one must cover this line like this at one end. So as you can see, this is the angle, and it passes through 90 here. As you can see here, this one, this point, it passes through 90 degrees. So that is the angle of rotation that you're going to have in this case. And we said it's clockwise rotation. So our angle is going to be 90 degrees clockwise. Okay, so that was it, guys, on this question. Transformation. So as you can see, transformation is actually nothing. You have got 12 marks for just doing this. 12 marks. So all you need, guys, is to work as much questions, and practice makes perfect, so that you know some of the answers that you're not even supposed to work with. So like I said, if you have to work with transformation, knowing all the isometries, that is your congruencies, your rotation, reflection, like this person did nothing. They had only one person on enlargement. All these were isometries. So it is much best for you to know those isometries in a good way, so that you avoid working out a lot of things which are not even necessary. Okay, and also make sure that everything is done. Sometimes your diagram is going to be looking dirty like this. Let it be like that. Do not erase anything. Leave them like that. Those are your marks that you are erasing there. So leave everything like that. Okay, so that's it, guys, for Meson African motives, working on O-level mathematics, past exam papers and revisions. For the meantime, till we meet again.